சார் லைவ் கொடுத்தாச்சு சார். ஸ்டார்ட் பண்ணீங்கன்னா மேடம் சாம்பரிங் பண்ணிட்டு இன்ட்ரோ கொடுத்தீங்கன்னா மேடம் ஷேர் பண்ணுறது அதை ஆரம்பிச்சுக்கலாம். சரி சார், ஸ்டார்ட் பண்ணுங்க சார். ஸ்டார்ட் பண்ணிட்டு மேடம் வந்து பேசுகிறேன். எந்த இல்லையா சரி ஜீவ் பண்ண இங்கே பண்ணா சார் ஒரே சொன்னா சார் அந்த மாதிரி முடியாது சார். பண்ணிட்டு மூவ் போயிட்டேன்னா சர்டிஃபிகேட் இன்ட்ரோ கொடுத்துட்டோம். அதுக்கப்புறமா கூட மாறி பண்ணுவோம்.
Hello,
Madam,
hello sir. கேக்குதா sir?
Okay madam, audible madam.
Hello.
Madam கேக்குது madam.
Okay sir, okay sir.
Research is to see.
சரிங்க சார். சார் என்னுடைய இது அனுப்பி விட்டுட்டுமா உங்களுக்கு?
And to think what nobody else has thought. Chemistry is being in the stores.
சரிங்க சார், சரிங்க சார்.
Which are the building blocks of matter and the core of.
சரிங்க சார், சரிங்க சார்.
Good morning to one of our present here, and now welcome you all for the second science and technology. Now I invite Miss G. Vimalam, Assistant Professor, Department of Chemistry, Sri Vidyamandar Arts and Science College, Uttarakhand, to welcome and introduce our chief guest.
A very good morning to one and all present here. I would like to introduce our chief guest, Professor Dr. C. Kavita, Ariman Arts and Science College, Uttangarai, Tamil Nadu, India. She obtained a graduate from Almeri Angappan College in the year 2002. She completed a master's degree at Sri Sharada College for Women, Salem, Tamil Nadu in the year 2004. She completed her Bachelor of Education at Annamalai University, Chidambaram in the year 2005. She completed Bachelor of Education from St. John's College of Education in the year 2009. She completed her doctoralship chemistry at VIT University, Bellu in the year 2014. Presently, she is working as Assistant Professor of Chemistry at Adiyaman Arts and Science College from 2014 onwards. She qualified as SET exam in the year 2017. She guided 11 MSc students and 1 MPhil scholars, and currently guiding 10 MSc students, 1 MPhil scholar, and 1 PhD scholar. She published 30 journals in international and national level. She attended 13 conferences and 6 workshops. She received Research Award from School of Advanced Science, VIT Units, Vellore. She received Award from IIM Bangalore. She organized international conference on emerging chemical science in the year 2014. Seminar on chemical science in the year 2016. Organized 2-day national level seminar on advanced nanotechnology in the year 2017. She organized a 1-day workshop symmetry, organic synthesis and nanomaterial in the year 2018. She organized a 2-day international conference on physical science to explain global challenges in the year 2020. She is a lifetime member in INS Bangalore. Concluding, I wish Professor Dr. C. Kavita makes successful and enlightening this conference. Thank you.
மேம் உங்க ஸ்கிரீனை ஷேர் பண்ணுங்க.
ஹலோ ஹலோ
ஷேர் பண்ணுங்க மேடம்.
ஹலோ சார்.
சொல்லுங்க மேடம். மேடம் உங்க ஸ்கிரீனை
ஹலோ சார்.
சொல்லுங்க மேடம். வாய்ஸ் ஆடியபிள்.
ஆடியபிள் ஆகுதா சார்?
ஆடியபிள் மேடம்.
எஸ் சார், எஸ் சார்.
உங்க ஸ்கிரீனை ஷேர் பண்ணுங்க மேடம்.
எஸ்.
சார் ரிமூவ் பண்ணுங்க கேக்குது.
அவங்க வந்து ஷேர் ஸ்கிரீன் போயிட்டு அவங்களோட
மேடம் உங்க ஸ்லைடு வந்து ஷேர் ஆகுது.
ஹலோ.
மேடம் சொல்லுங்க மேடம். மேடம் ஓகே.
ஹலோ.
மேடம் ஸ்லைட் ஷேர் ஆச்சு மேடம். ஷேர் ஆகுது மேடம்.
sir.
Okay.
Shall we start, sir?
Okay, madam, sir.
Okay, sir. Very good morning to respected dignitaries from various institutes, various colleges, convener, coordinator from Vidya Mandiri Arts and Science College. I am very happy to my share research knowledge in this occasion. I am very thankful to management, chairman, convener, coordinator of this college to give this wonderful opportunity of today. Now let us go to my session to explore the knowledge of polymer application in coating and food packaging system. First of all, we know the polymer. Polymer is a smaller molecule combined together to form a macromolecule. This polymer we have to use in day-to-day life, daily in this world. Next, this polymer we have three categories. It says natural polymer, synthetic polymer, and then semi-synthetic polymer. So natural polymer, they occur naturally, that means found in plants and animals. Example is protein and cellulose. Semi-synthetic, it made of from man. So example is plastic or nylon 66, everything. In semi-synthetic polymer, different from natural and synthetic because it is occur in naturally and then it undergo chemical modification. Mainly this cross-linking polymer. The cross-linking polymer, we have macromolecule. The macromolecule, it can be classified into dendrimer and hyperbranch polymer. First of all, we see the dendrimer. Dendrimer, actually, it is a global-like structure. And then it shows the good entanglement. And compared to hyperbranch polymer, it is very good chain entanglement. So now we see the hyperbranch polymer. It's actually highly branched macromolecule and then three-dimensional. You see this is the outline of the hyperbranch polymer. The dendritic unit, terminal unit and linear containing so many units. And first of all, we see the terminal and linear and dendritic unit. What is the special feature of this hyperbranch polymer? Actually, it have your high solubility, activity. Mainly, it focuses on non-Newtonian behavior. Actually, what is meant by non-Newtonian behavior means it is low viscosity. It have a high molecular weight, and also in exterior manner, it have a large number of functional group, globular structure, and also it containing highly reactivity and still chain entanglement. Next, we see the application of this polymer. Actually, this application mainly we have to focus the drug delivery field and then additive properties. And as we move to the coating field, we have so many applications there. Example, powder coating, highly solid coating. Sometimes it is give the good low volatile coating, acrylic coating. Some important application is it acts as a nano catalyst and it is used in a biosensor application in this hyperbranch polymer. Next, we see the synthesis of this hyperbranch polymer. It can be synthesized to single monomer methodology and then double monomer methodology. Already we know the single monomer because it is a very simple method, that is a polycondensation method. But this polymer we have to prepare mainly in double monomer methodology. This methodology is contains so many types. Example, A2 plus B3, A2 B23. That is what is mean by this A2 B2 means A2 is a core molecule, B3 is a chain extender. So we have to react together these two polymer. We are getting the hyperbranch polymer. It is a good like three-dimensional structure. So many authors was proposed this methodology. It's follow the single monomer, double monomer, and coupled monomer methodology. So this synthesis manual, why we are using this hyperbranch polyester means it have in exterior core molecule have a multifunctional compound. So this multifunctional compound easily encapsulated with other monomers, that means other polymers. So it is give the good application in coating technology. So first of all, we see the hybrid coating. Hybrid coating means this is one of the example in polymer field. It is good application. This hyperbranch polymer actually blend together with some filler. Example here, titanium dioxide and K10 clay. Sometimes we should use in silica. Everything we blend or incorporated together this coating material. So it shows the good properties. Example, that means thermal properties and then toughness, surface hardness, everything increases. So next we move to the powder coating. Suppose powder coating, this polyester we crafted together some allyl or methoacrylate polymer. We have to use this. Suddenly, some properties will be increases. Example, gross chemical resistant, durability, sometimes pencil hardness, everything increase in the powder coating. Next, we see the UV curable coating. UV curable coating, this hyperbranch polyester, we incorporated her. Hello, sir. Share avling. Sir, sir, அப்போ நீங்க இது பண்ணுங்க சார், நான் அதிலே பார்த்து இது பண்ணிக்கிறேன்.
மேம் ஸ்லைட் ஷோ பண்ணிடுங்க மேம். மேல பாருங்க, டாப்ல
அனுப்பிட்டேன் சார், நான் உங்க இதுக்கு மெயிலுக்கு அனுப்பிட்டேன் சார். அனுப்பியிருக்கேன் சார். ஓகே சார். சார், சார். ஆமாம் சார், ஜிஎஸ்டின்னு அனுப்புனீங்களா, அதுக்கு அனுப்புறேன் சார். இல்லைன்னா உங்களுக்கு இதுக்கு ஃபார்வர்ட் பண்ணிட்டீங்களா வாட்ஸ்அப்புக்கு? ஓகேங்க சார். Hello sir, start பண்ணவா sir? Okay sir. Good morning to one and all present here. Now let us go to my section to explore the knowledge of polymer application in coating and food packaging system. Next sir. First of all, we know the polymer. Polymer actually it is a small macromolecule. Example, natural polymer, synthetic polymer. This polymer material we have to use in day-to-day life. This polymer it can be classified into 3 types: natural polymer, synthetic, and semi-synthetic. Next. Sir, next. Hello. Hello, sir. Next, sir. Sir, next po சொன்ன போல. சார் இல்லைன்னா என் ஃபோன் மூலம் வரட்டுமா சார்? இது கனெக்ட் ஆகல, வேணா ஃபோன் இதில் வரேன். சரிங்க சார். உங்கள் ஸ்லைடு ஃபர்ஸ்ட் ஸ்லைடு முடிஞ்சது சார், செகண்ட் ஸ்லைடு சார். இது விசிபிள் ஆகல சார் இங்க. சார் இப்போ நான் ஷேர் பண்றேன் பாருங்க சார், தெரியுதான்னு பாருங்க. இருங்க ஒரு நிமிஷம். மாத்திட்டாங்களா சார்? சரி சரி சார். அதுதான் எனக்கு விசிபிள் ஆகல சார். கண்டினியூ பண்ணு. Okay, sir. Next slide, sir. Okay, sir. Natural. So we see the natural polymer actually found to plants and animals. So majorly we have to do the macromolecule. This macromolecule is classified into dendrimer and hyperbranch polymer. First of all, we know the dendrimer. Dendrimer is a good like a globe-like structure. It look like a macromolecule. Next, we see the hyperbranch polymer, actually three-dimensional architecture. It is highly branched molecule. This is an overview of hyperbranch polyester. It containing three units, dendritic, terminal and linear units. Next, we see the special feature of hyperbranch polyester. Actually, this polyester have so many good properties is there. First of all, we see the solubility and the non-Newtonian behavior. Actually, what is mean by non-Newtonian behavior means it is a low viscosity and a high molecular weight. This polymer containing large number of functional group and then highly reactivity, enhanced comparability and a little chain entanglement. So next one, we see the application of the hyperbranch polymer. We have a next slide, sir. Application of hyperbranch polymer in mainly it shows the good drug delivery and blend components. It used in the coating field. It have a various coating is there, such as powder coating, acrylic coating, hyperbranch antimicrobial coating, and VOC coating. Sometimes it is used to catalyst, nano catalyst, biosensor application, and liquid crystal application is there in hyperbranch polymer. Next, we see the synthesis of hyperbranch polymer. Actually, how we synthesis this hyperbranch polymer, we have two categories there. First is a single monomer methodology and then double monomer. Actually, you know, the single monomer methodology is a simple one, polycondensation method, but we prepare the hyperbranch polymer from double monomer methodology. This methodology, we have get a term, many types is there. Example, A2 plus B3, A2, B2, B3 method, coupling monomer method. First we know the A2 plus B3, that means a core molecule and chain extender. So many author was investigated this polymer synthesized from different methods, single monomer, double monomer, and then couple monomer methodology. Next, sir. Next we see the how you prepare the polymer, why we are using this hyperbranch polymer in coating technology. Next, sir. In hyperbranch polyester is containing large number of N group in the exterior core, so it easily encapsulated to other monomer. It is used in the acrylic, that means polymer field, coating field. Next, sir. So why it is used in coating film means it is a good non-Newtonian behavior. That means low viscosity and even height at high molecular weight. So it is so the coating film. Example powder coating, acrylic coating, UV and hybrid coating. Next, sir. Next, sir. So first we see the hybrid coating. Hybrid coating, first we prepare the hyperbranch polymer. This polymer actually blend together with some filler. Example, titanium dioxide, K10 clay, silica. We have to use any silly. It is give the good hardness and surface hardness strength. Next we see the powder coating. Powder coating also same procedure. We have to prepare first hyperbranch polyester. It's grafted together some allyl or methyl acrylate. What is the important application of this powder coating? It shows the good chemical resistivity and durability. Next we move to the UV curable. So UV curable coating, same first we will prepare will prepare the UV coating polyester is incorporated or encapsulated with some acrylic acid or fluorine. Sometimes we are using vinyl ether. It gives a better result compared to the ordinary polymer. It is a good additions property like a chemical resistant, and it have a low sinkage. Everything's good for this hyperbranch polyester. Next, why we are using silver? Silver is a good antibacterial activity. You see next slide. Here, so Zhang et al., Roy et al. Actually synthesized polymer, different polymer, polyamine, some ester. This polymer actually some synthesized together, reacted together with silver. It gives the excellent durability and excellent antibacterial activity, and also increase the concentration of the active agents. Next, sir. So first we will see this is a hyperbranch newly prepared the polyester. This polyester in exterior manner, the external position is having so many functional group. This functional group easily modified with some polymer. Example, acrylic acid, meta-acrylic acid. So it react with some polymer is give the good sinkage and addition properties. This polyester is reacted together some metal nanoparticle. Example, silver, iron, copper, everything. But why we have chosen for silver means it is a good antibacterial activity. So it is easily blended together the nano polymer is give the good antibacterial activity. Next, we see the synthesis. Synthesis first is a B2 monomer, next A3, A2 and B3. This is a A2 and B3 approach of the polymer synthesis. So we are using catalyst, some catalyst and 120-degree temperature in presence of inert gas, atmosphere, nitrogen inert gas is give the hyperbranch polyester. This is the first generation. So we will prepare the generation wise G1, G5, G3 and G7. We give the generation wise. We should prepare the hyperbranch polyester. Next. So this is the fifth generation of hyperbranch polyester. It's a very big macromolecule because we reacted different ratio. Stoichiometry ratio will be very different. So it is prepared the highly macromolecules. Next. So this is the FTR spectrum of different generation of polyester. We see a generation like G1, G2, G3. We synthesized any polyester or polyamine. The intensity of the any peak, hydroxy peak, suppose ester peak, it will be increases because we increase the generation. Generation wise increase this ratio. The intensity of the peak ratio also increases. And next we see the proton NMR spectra. This spectra also shows generation wise G1, G2, G5 generation wise the spectrum intensity it will be very clear. Next. Next is you see the properties of a hyperbranch polyester. So the different generation we take the molecular weight of hyperbranch polyester. That means polydispersity. Already you know the polydispersity. That is the number of molecular weight ratio and they divided by number of weight average molecular weight. So generation wise the degree of branching, intensity, viscosity, N group, polydispersity, everything will be increases. Next, we see the solubility. Already you know the polar and non-polar solvent. We take some polymer is reacted together water or any polar solvent, non-polar, but it is give the better result for polar solvent. Next. This is a synthesis of acrylic modify. We will prepare the hyperbranch polyester. This ester is combined or reacted together some polymer. Example, acrylic acid or methyl acrylate. This is a filler of this reaction. Filler or blender blend together this polymer is give the some modification of polyester. So next we see the curing property. Next. Hello. So synthesis of acrylic modified hyperbranch polyester, we see the curing property, sinkage, UV addition, everything we will prepare.
Next one. Name. Potential. Look, சார் கிட்ட சொல்லி வேற கூட dissolve oxygen உங்களுக்கு எக்ஸ்மெண்ட் ஆல்கலினிட்டி இந்த எக்ஸ்மெண்ட்
So now we have prepared the acrylic modified polyester. Now we see the sinkage addition and UV curing properties. Sinkage properties is show the good percentage. Addition also is found to be 4B and UV curing result within 10 minutes it give the fast drying properties. Next. This is why we are using silver and how we prepare the silver nanoparticle. Next. So this is the hyperbranch polyester. It is the 5th generation. This polyester is reacted with silver nitrate. Silver nitrate, your metal. The silver metal is easily encapsulated to the hyperbranch polyester, but it presents in the intentional position. So it easily reduce with sodium borohydrate. It gives the silver nanoparticle. Next. Next we see the UV spectrum and XRD spectrum of nano silver polyester. It shows the good result for both UV and XRD. Next. Next, we see the TEM and FTR spectrum. Already you know the silver particle is a spherical shape. This image, TEM image shows very excellent spherical shape of the hyperbunch polyester. In FTR spectrum also shows in ordinary polyester and then nano polyester, the intensity will be less because the carboxyl group easily incorporate to the polymer. So the intensity will be decreased for ester peak. Next. This is a TGA curve with ordinary ester and nano silver. This nano silver shows good thermal stability for ordinary polyester. Next, see the antimicrobial activity. You take this hyperbunch polyester. We are doing the antibacterial activity against SRS and E. coli bacteria. Next. So we see this is a E. coli bacteria, another one is SRS bacteria. These two bacteria, the E. coli bacteria shows enhanced antibacterial activity compared to the another bacteria. Yes. So finally we do the conclusion. This hyperbunch polyester is very easily soluble in water. It reacted together the B3 and A2 monomers in different generation. So increase the generation, the polydispersity and molecular weight, and also N group analysis, the UV curing, sinkage, addition properties, everything excellent for this polyester, and also show the good antibacterial properties. Next. So polymer, this is a polymer food packaging. The main purpose of food packaging is to keep food content from contamination and damage caused by the exposed to the outside world. In this day and age, remarkable of these changes occurring in the application of packaging material like ceramics, metal, paper, and polylactic acid, some polyethyl acetate, everything are widely used for the core material for food packaging. So food packaging is mainly is packed for food. It's a protection of some tampering resistance, some special chemical and biological application. What is the main protection? Physical protection, barrier protection, and contaminate protection, and then information transmission. Next. So natural cellulose fiber. We so many people has done the food packaging material from synthetic, but we have chosen for the fiber is a natural cellulose fiber. Example is aloe vera. Aloe vera is containing so many vitamins, proteins, amino acid, cellulose, lignin, ester, everything is there. These leaves are used to tolerant properties and low blood sugar level. It reduces the low blood sugar level, and also it have some physical properties. Next. So what is the application of this aloe vera cellulose fiber? It is actually it is having some hydrogen bond between the chain entanglement, and also without loss of biological activity on the good inflammatory, analgesic properties, everything there. So this fiber easily added together some polymers. Yes. So why we are using aloe vera? Because it is a natural fiber, easily combined together to the other molecule. It forms a uniform film, that is a packaging film. So we see the next. So many authors were synthesized food packaging film from polymer, that means synthetic polymer. Example, cellulose acetate, glycine, some extract, phenyl hydrazine extract, ginger cherry extract. It give the packaging film, but we are using the pure natural polymer. Next. So this natural aloe vera polymer is blend together the polylactic acid. This polylactic acid is one of the natural polymer. It is having high molecular weight, but is insoluble in water, and it is renewable source. It produces some renewable source. Generally, it prepared from rice, wheat, sugar cane, starch, protein. This is a very good biodegradation polymer, and then non-toxicity ability. So this polylactic acid, it added together aloe vera gel in casting method. Next. So what is the importance of food packaging? In plastic packaging is essentially we are using in nowadays because it is a big environmental issue, biodegradable polymers, and also it affect the pollution. So we are using natural polymer, everything it will be avoided. So that only natural cellulose fiber easily reacted with polyester, polylactic acid, because polylactic acid also natural polymer, and then aloe vera also natural because aloe vera possess some cellulose content. Next. So this is a synthesis method. It is a casting method. So we are taking natural aloe vera, it poured to PLA. This both are dissolved in solvent. The solvent is a chloroform because PLA and both are easily dissolved in chloroform. We separate in petri dish. It is poured to the petri dish. You are wait for the 2 or 24 or 48 hours. We are getting the polymer. That means food packaging film. Next. This is a preparation of natural cellulose fiber. We are taking chloroform as a solvent. PLA and aloe vera both are natural polymer because PLA are prepared from starch and the powder, everything, sugar powder. Aloe vera, both are blend together with chloroform. We keep the reaction in magnetic stirrer. After 24 hours, we get the film. This is a film. This is a food packaging. We see here. This is a film, the food packaging film. Next. We see the FTR spectrum of this polymer. We will prepare different ratio, 1:2 or 2:1, 2:1, 2:2. We prepare the different ratio. We have to take the FTR spectrum. Both are showing good result, not that much of a difference, but 2:1 show a good intensity peak compared to the 2:2 ratio. Next. This is XRD spectrum of 2:1 ratio. Next. Next, sir. This is 2:2 ratio. Both ratio, the 2:1 ratio shows best result because it is having a three-dimensional polymer lacking. It is a stable supramolecular structure. And next. Next, we see the hardness of this polymer. This is a natural polymer, cellulose-based polymer. We see the pencil hardness and gauge hardness. Everything is good for 2:1 ratio. Next. This is water absorption. It is ordinary you are doing in your lab. As usual lab, first we cut the film in 1 centimeter to 1 centimeter square shape. We wait. This is wait to water. After 24 hours, up to 1 week, you have to take the reading. We will get the good absorption for 2:1 ratio. Next. This is a water absorption percentage of the each polymer. We are taking ordinary neat PLA, combine together aloe vera. The 1:2:1 ratio only shows a good result. That means better result. That means enhanced result for the PLA with 1 percentage of the aloe vera. Next, sir. It's a chemical resistant. This also you are doing in the lab. Same procedure. You cut the film for 1 centimeter, 1 centimeter. After keeping, you have to take the weight. Check your 12 hours, 12 hours, 24 hours. You are taking 12 hours. We are getting good result. Same. 1:2. That 2:1 ratio of the polymer shows the good result. Next. Next. Hello, sir. Next. So this is a chemical resistant. You are taking film, you cut it small pieces. Is dipped into some solvent. Example: acetone, ethanol, HCl, benzene. Sometimes the chloroform. Everything we are dissolving. After 24 hours, the benzene shows a good result. Next, sir. So this is a curve for the chemical resistant of acetone and ethanol. Next. This is a HCl peak for cellulose-based polymer, and another one is a benzene. The both ratio, the 2:1 ratio shows enhanced chemical resistivity. Next. So the same thing for 2:2 ratio, we dipped in this different solvent, we are getting the curve. Next. So the contact angle actually is done in Hanoi University. This contact angle, say the natural fiber, we cut into square shape. It is wettable to PLA film. What is the range of this contact angle? 0 to 90 degree. But PLA film shows here wetting contact angle below 90 degree. So below 90 degree is a good activities. Next. So this is a contact angle film of natural based PLA film. It is a 2:1 ratio. Another one is 2:2 ratio. Both are shows a below 90 degree contact angle. Next. This is SEM analysis. We are taking both 2:1, 2:2 ratio of morphology of this SEM image. So some voids, cracking voids. In the surface, we have here some cracking voids of surface of PLA film. So SEM image shows the some voids of the cracking film. Next. So antimicrobial activity, we are taking this film is dissolving some solvent. It against with some bacteria, SRSS, E. coli bacteria, Phagomonas bacteria. In compared to 3 bacteria, E. coli shows a high resistivity for both ratio 2:1 and 2:2. This both ratio 2:1 shows a excellent result against E. coli bacteria. Next. Its conclusion, this aloe vera actually content of vitamin, protein, amino acid is easily available in market, everything, a garden. So we aloe vera is a present study. It is bio based polymer. It is combined together the lactic acid, that also natural polymer. So we preparing the packaging material. It is good for human environment, human health, everything. It is high elasticity and also high melting point, and it is low environmental hazardous material. So it is a good food packaging film. Thank you. Thank you, sir. Thank you.
Thank you, madam.
Okay, sir. Okay, sir. Thank you very much, sir.
Okay, thank you. Just wait for 2 minutes, madam.
Okay, sir. Okay.
I thank our chief guest, Dr. K. Kavita. She explained clearly about polymer applications in coating and food packaging system, types of polymers, and explained uses and special features of polyester, and clearly explained the applications of hypersynthesized polymer, and briefly explained about HPEP coating. Then she explained how silver is used, explained about schematic representation of nanoparticles, antimicrobial activity, food packaging, importance of food packaging. Thank you for your mesmerizing presentation, ma'am. And once again, thank you, ma'am. Now I'd like to invite Dr. Dayanandan, Assistant Professor, Department of Chemistry, Sri Vidyamandir Arts and Science College, to honor and
Thank you,
introduce
sir.
our chief guest.
Sudarshan, unmute button.
Can you hear my voice? Dr. Govindraj?
Professor. Just wait for 1 minute, Professor.
Yeah, just.
Good morning to one and all present here. I'm proud to invite Dr. S. Sudarshan, MSc, MPhil, B.Ed, PhD. His education qualification: BSc Chemistry from Islamic College, Vaniambadi, MSc Chemistry from Islamic College, Vaniambadi, MPhil Chemistry from Islamic College, Vaniambadi, B.Ed Physical Science, V.S. Isaac College of Education, Arakonam. He done his doctoral in chemistry from Periyar University, Salem. His academic profile: the area of interest is synthesis of various biopolymeric and biodegradable hydrogels, green chemistry synthesis, solventless synthesis. His professor, his academic career and teaching experience: the professor has worked in Arinyaranna Arts and Science College during the year 2008 to 2009, and in Ranipat Engineering College, Valaja, from 2009 to 2012, and C. Abdul Hakim College of Engineering and Technology, Ranipat, from year 2012 to till date as an assistant professor. Now he is working as an associate professor in C. Abdul Hakim College of Engineering and Technology, Ranipet. Professor has well-organized many seminars, symposium, and co-curricular activities like online national level e-quiz named Environmental Day in the year 2020, FENMAC Association year 2019, Environ 19, Erudition in the year 2015, Hakim Career Guidance in the year 2016, arranged many industrial visit in the year, is a coordinator in he had guided many projects and guiding many projects for BE and ME, environmental science, civil and engineering students. His publication, total number of publication, nearly 25 publications from national and international level. His Google Scholar citations 146, total impact factor 47.62, H index 8 and I-10 index 7. Research gate score is 19.65. He attended many online FDP webinars, e-quiz and workshop. I invite Dr. S. Sudarshan to this wonderful session to give their ideas about the smart hydrogels. Thank you, sir.
Good morning, sir. Can you hear my voice?
Yes, Professor.
Is my PPT is clear, sir?
Okay, clear.
Yeah, clear. Okay. Good morning. Thank you, Professor, for your nice introduction about me. And once again, I thank for the management and Department of Chemistry and head of the department and other all teaching and non-teaching staff members regarding the working of first international conference in the Vidya Mandri Arts and Science College. And I once again thanks to all the earlier speakers and the keynote address, and also my Gurunathan yesterday. My guide is also present a beautiful materials applications, and already you are well known about that. I am Dr. Sudarshan, working in the Abdul Hakim College of Engineering and Technology, and today I am going to discuss a smart part of my researcher, that is smart hydrogel as multifunctional biomimetic system. And this is the outline presentations of my small work, and it is going for discussing about the historical background, classification, stimuli responsive hydrogel and their nanocomposites, how it is fabricated, and how it is biodegradation takes place in different technique, and finally we can apply some application and we can just move. So this is the hydrogel basic. We are well known about that. The gel is already we are well known of, but behind that hydrogel, we need some conclusion, that is three-dimensional poly network is always available in the net hydrogels, because it retain large amount of water molecule as well as biological fluids due to the presence of hydrophilic groups and also polymer chain flexibility. Both the two things is always withstand more amount of water molecules, and based on that, it is always insolubility in water, and the property is always good mechanical and physical property, and moreover it's a soft and fragile natures, and many examples also available there for diapers and tissue engineering. All the things is also available. And based on the hydrogels, we well known about that. These are the image, and most of the gels is also preferred by medical application, environmental applications like that. I will show some few applications related with the silicon-based hydrogel, super absorbent and water beads of hydrogels, cellulose hydrogels, food packaging hydrogels, and multicolor hydrogels. Nowadays, most of the food packaging material is always based on the gel, and also your biodegradable natures. And this is the historical background, which is always present for hydrogel, how it is present and exists for more than half of the centuries. Using hydrogels began for therapeutic applications like contact lenses. Look at the above images, we can easily observe the contact lens is always used for nowadays, because the sensitivity of eye power is always low. And 1954, that is when Lim and Mitchell laid that is synthesized polyhydroxide methacrylate compound, that is which is widely used for contact lens productions. So this is the first history before that half of the centuries. And now we can move for the classifications. Just a minute. So here the classifications and is based on the nature of site groups, stimuli responsive hydrogel, method of preparations, mechanical and structural characteristics, physical structures, and these are the classifications of hydrogel. But when we are going to look at the normal classification, as well as the significant parameters also available, like biodegradability, biocompatibility, mechanical strength, and easily injectable, high water absorption tendency. All the things is a most important and vital role for our day-to-day life of applications. So this is the general classification of hydrogel, which is always used for the origins, durability, response to the stimuli, charge, structure, compression. So whenever you are going to choose for the preparations or manufacture of any hydrogel, you must be focusing which type of origin you are going to select and how that is used for the future application as well as present applications. And apart from that, it is widely used for the industrial as well as medical applications. All the things we can just observe. In my point of view, I'm just focusing the origin, natural origin. That is synthetic and natural is also available. But the synthetic is having some disadvantage while you're going to look at this one. And durability, the final product, most of the industrial product like polyethylene glycol and polyvinyl product, all the compounds may have some non-degradability. So based on that, I just want to focusing the biodegradable natures of responsive hydrogel is preferred via using simple and low-cost materials. And apart from that, the responsive, stimuli responsive hydrogel, that is smart hydrogel. It can be sensed by temperature, pressure, is magnetic, electrical, pH sensitive, all the natures. And charge, the charge is also most important parameters, because the cationic, anionic, neutral, ampholytic nature is also available. But I just focusing right now anionic natures as well as the cationic nature, because each and everyone having some peculiar characters. I will discuss in the later slide. So in that kind of view, that charge is also most important, and the structure, whether it is a semi-crystalline as well as amorphous natures, all the things we can just observe. And then composition, and you must know the composition of homopolymer and copolymer. So these are the many different type of polymer which is available in the nature, as well as synthetic polymer available in the market. The alginate, dextrane, xanthine, quarkum, cellulose, fulane, pectine, hyaluronic acid, gelane, okara gum, citric acid, itagonic acid, all the coming under the natural polymers. Whereas in the case of polyvinyl alcohol, acrylic acid, methacrylic acid, polystyrene, polyvinyl pyrrolidine, and polyethylene glycol, and chitosan, polypropylene, nylon, polyethylene, many things is always coming under the synthetic polymers. So these are the few methods available in the fabrication of hydrogel and the nanocomposites. So in general, we have some three different type of factors, which is physical method and chemical method and biological method. Apart from that, the physical method is having some low mechanical stability and some kind of drawbacks is also there. And focusing that chemical method is also available, sol-gel method, chemical vaporization, and colloidal method is also available. But when you're going to look at the physical method as well as the chemical method, the biological method is more important parameters for nowadays, because each and every parameters which is going to in the society, you must be focusing the synthesis and other part. Your product is always not is not affected for human as well as environment. So in that point of view, the green chemistry is always insisting 12 principle. So one of the principle is solventless approach method. So based on that principle, I am using throughout the reactions mint leaf extract using as a reducing agent, because it's having some peculiar characters, and also some of the composition of the ingredient is also present in the natural mint extract. So the green chemistry method, that is insisting always your synthesis part of or manufactured part of the product is always suitable for environmental without any further effect or further defects of our human as well as environment. So this is the stimuli responsive hydrogel. We already well known about that: glucose sensitive hydrogel, mechanical, redox sensitive, enzyme sensitive, and photosensitive, thermal sensitive, magnetic sensitive, electrical sensitive, and pH sensitive. So based on that, I just focusing the pH sensitive hydrogel. I just look at the above images. We can easily observe the unswollen or dry hydrogel is having small size. When the preparation of the hydrogel, dry hydrogel, it should be poured or immersed in the particular solvent, like a pH solution solvent. What will happen? It absorbing more amount of water molecules, and it shows some expansion of the swollen hydrogel. So from that, it shows some, whether it's anionic nature or cationic nature, both it is undergoes some swollen hydrogel is absorbed. Depends upon the chemical which you are going to select for the solvent. For example, anionic hydrogel, it's more swollen in always observed in the basic medium. For example, sodium alginate hydrogel is poured into the sodium hydroxide. What will happen? It absorbing maximum water, as well as its expansion is also swollen nature is also very high in the basic medium. Whereas in the case of cationic hydrogels, like chitin, chitosan, that kind of material, which is always focused on the cationic natures, and it is always good swollen in the acidic natures only, because its H plus is present, and it will always show some things. So based on, I will focus in the stimuli responsive hydrogel. So this is a simple things, which is a pH sensitive polymeric hydrogel, and apart from that hydrogel, stimuli sensitive hydrogel, and pH sensitive hydrogel. So when you're going to look at the alginate is a good example. Acidic pentane group is also available, and due to the presence of some hydrophilic functional groups such as acid, sulfonate, all the polymers chain in the cationic hydrogel is also available, and this is due to the presence of some basic pentane groups such as CO, NH2. Cationic hydrogel, you people must be focusing the application. So based on the pH sensitive polymer group are ionized. Whereas in the case of higher pH, the carbonyl group are ionized, carbonyl group are repel each other and causing at least to swelling in natures. So these are the monomer which is going for preparation of a small part of a research part, that is sodium alginate, ethylene glycol, acrylic acid, and sodium alginate is a natural renewable resources, and it is always coming from the natural one. And what is the things is always polyfunctional group and polyol and non-toxic natures and easily biodegradable and biocompatible, readily available and inexpensive. So based on that property, sodium alginate is the backbone of all the compound. And ethylene glycol, we are going to choose three different type of ethylene glycol, diethylene glycol, triethylene glycol. All the natural is always improve the hydrogel because the flexibility and toxicity of the compound is always lesser. And acrylic acid is also used for the backbone of sodium alginate based hydrogels. And this is the schematic representations of our hydrogels as well as the mechanism. The sodium alginate react with the first diols, and it is undergoes first reaction with the first step. Condensation polymerization takes place at 80 degrees Celsius to obtain pre-polymer. So that pre-polymer containing some of the functional group, when it is added acrylic acid to finding beautiful hydrogel is based on the monomer as well as the backbone of sodium alginate, that is sodium alginate, ethylene glycol, and diethylene glycol, triethylene glycol based hydrogel. So from that, the first step is condensation. Second step, free radical polymerization mechanism always takes place. And just look at the mechanism here. What will happen? The hydrogen network, the inter and the intramolecular hydrogen bonding is takes place. So from that, the three-dimensional network is always stable at the particular stage. And this is the swelling. So what is swelling? The swelling is nothing but the compound or material which absorbing maximum amount of water molecules or any other physiological body fluids at suitable solvents such as basic medium solvent or suitable solutions such as basic solution or acidic solution, and the swelling. And you can just observe the image. You can easily in the left side image that is clearly explained. Unswollen or dry hydrogel is a slow or there is a minimum size of the hydrogel. Whereas in the case of after swollen hydrogel, it particularly immersed in the particular solution. What will happen? The swelling equilibrium is attained at the maximum at the greater. You just look at the graph that is clearly explained. The pH is 4, 6, 7.4, 8, 10. And the swelling equilibrium is always calculated by using the equations like swelling equilibrium percentage, weight of the equilibrium minus dry weight of the compound and divided by dry weight of the compound into 100. So we can easily obtain the swelling equilibrium of the compound. So the pH is low, the compound possessing only 700, whereas in the case of pH is 6, the compound obtained 2400 swelling equilibrium. Likewise, pH 4, pH 8, pH 10. That maximum 6392 swelling equilibrium is always obtained and increase the pH. So the graph that clearly explains the swelling equilibrium is always directly proportional to the pH of the solution. When the pH of the solution increases, the swelling equilibrium is also increases. And my one of the friend, Dr. Franklin, is also insisting the result of citric acid based hydrogel that possessing only for 2500 something of swelling equilibrium, whereas in my compound that possessing more than 6000 swelling equilibrium. From that it concluded this kind of swelling equilibrium attaining or water tendency very good for our sodium alginate based hydrogels. And based on that, the hydrogel, we move towards the next part of the research, that is the need of green approach method. So far many researchers have synthesized inorganic nanocomposite. Already we are well known about that, whether it is using physical method or chemical method or cross-linking method. So all these things, they are possessing some toxic chemicals which are harmful to living systems, were used for the reductions of inorganic particles. To solve this problem, researchers have introduced the green process or green approach method. So I just think about the already they are mentioning some of the compound which is used for the natural ingredient. But apart from that, why I am choosing this kind of material for acting as a reducing agent for plant leaf, because it's a low cost and available eco-friendly material and biodegradable nature, and moreover it's a simple and non-toxic materials and simple methodology. So this is that is simple that is images that shows some mint leaf, that is Pudina is is natural reducing agent, and this is highly biologically active compound because it containing flavonoids and phenolic compound which is acting as a reducing agent, and moreover it's occurring in nature and non-toxic excellent bioactive agent for wound healing properties. And also is a discovering of these new biological sources for the synthesis of silver nanoparticles are more advantageous due to available and cost-effective methods. And the sodium alginate is a polyol and polysaccharide, and why we are preferring, because bioadhesive natures of wound surface, sufficient water vapor permeability and elasticity and high mechanical strength, and compatibility with the topical therapeutic agents and optimum oxygen permeability is always observed. And moreover, the sodium alginate polysaccharide easily undergoes biodegradability. So based on that, it's a non-toxic in natures. And this is the scope of our present part of the work is a simple and convenient method, and water acts as a solvent. And throughout the reaction, I'm not using any kind of DMF, DMSO4 or THF, all the solvent, because it's toxic natures. And the final obtaining product like cellulose as well as the hydrogels, that is polyol based hydrogels and nanocomposites, is always biodegradable in natures and moreover eco-friendly polyol. So that conclusion is clearly explained throughout the reaction. I'm not using any kind of no cross linker as well as the organic solvent, and that clearly explained the green approach method is always follows. And this is the fabrications of silver biocomposite hydrogel, how it is sourced. The first image already we are well known about that. Sodium alginate react with diol. We can get some free polymer in the presence of acrylic acid to source the white color. Then after that, mint is adding in the presence of silver nitrate solution. What will happen? A brown color precipitate is obtained. So that brown color compound that shows some formation of the silver nanocomposites. So here, the simple scheme that is represented, the image is shows dry hydrogel is yellowish color. You just look at the image. Then after that, the dry hydrogel is immersed in the particular solvent or solution. What will happen? It absorbing maximum amount of water molecule. Then its swirling nature is always observed. Then the swollen hydrogel should be immersed in the silver nitrate solution, because the Ag plus, already I told that the swollen hydrogel is a network, three-dimensional network. It having some holes, cavities, and hollowness. So that hollowness and cavities it allow Ag plus ion inside the hydrogel network. And finally, when we are going to added the swollen hydrogel into the particular Ag solutions, the mint extract solution is added. And after few minutes, what will happen? The all the compound that is a hydrogel network, it absorbing Ag plus, that is also containing Ag plus ion, it should be converted to Ag0 ion. That is confirmly shows the formation of biocomposite, that shows the formation of color. And this is a schematic representation and mechanism of fabrication of silver biocomposite. Originally is published in the Polymer Plastic Technology and Materials. And here the sodium alginate reacts in the ethylene glycol and reverse condensation reaction in presence of acrylic acid to form three-dimensional network. And just focusing the three-dimensional network, it holding COO minus group. So that anionic nature of the group, when it is undergoes immersed in the particular AgNO3 solution, what will happen? The Ag plus it should be incorporated or easily enter into the hydrogel network, it form Ag plus. Then silver nitrate particle, that is silver nanoparticle, is always formed in the presence of mint leaf extract is added. And finally, we can get the silver nanocomposites. So that shows the images. So this is clearly explained. The formation of biocomposite is always a very simple and convenient method for the preparation of bio-nanocomposites. And these are the few images it is used for in our laboratory. That is my hand, and it is always possessing a different type of gel holding is also available. And there is the formation of silver biocomposite hydrogel is also present in the laboratory. And based on that, the IR spectra is also done. Here, some of the important peaks is also observed. The blue color spectra shows the SCA hydrogel. When we are going to look at for the SCA, ethylene glycol based sodium alginate nanocomposites, and moreover, here the low concentration, high concentration, 2.5 is the low concentration and 50 is the high concentration. Both the two is compared with the parent hydrogel. What will happen? Some of the important peaks like CuO and OH group is always shifting due to the corresponds van der Waals force of interactions, Ag plus ions as well as the anionic hydrogels. So in these mechanisms that clearly explain, the Ag plus ion is a cation and anion hydrogel network is also available. There is a electrostatic attraction is there. So that is a certain amount of Ag nanoparticle, silver nanoparticle as distributed into the silver biocomposite, and it shows some matrix formations. So from that, some lower wave of the numbers, that is clearly evidence for the formation of silver nanocomposites. And these are the few images of STEM images. The scanning electron microscope is always some shows the roughness, and AB is a dry hydrogel. That is only hydrogel. There is no any formations. That is, it shows the uneven sponge roughness, and cavity is also available. Whereas in the case of C and D, shows the 2.5 low concentration of silver nanocomposite. Some cavities and macro sponge is also available, and here the Zal surface area, and the background is also shows some of the compound is always shows some cubic natures and also granular structures. And E and F is 50, that is shows some cavities and macro sponge structure. So all the things that are clearly explained when we're going to compare for a raw material, that is parent hydrogel as well as the nanocomposite hydrogel, that encourage the some changes of cavities, macro sponge structures, and cubic structures. All these things is always shows the formation of nanocomposite. So once the large surface areas always increases, the swelling is also increases. There is a perfect cavity and roughness on the smooth surface is also increases when you're going to add silver nanocomposites. So this is the equilibrium swelling of ethylene glycol based hydrogel and equilibrium water content. Why I'm telling this one in human body that containing only for 60%, minimum 60 to 63% of water molecules, whereas in a compound is always shows the all the pH level that shows above 70% of water molecule. So that clearly explain this kind of equilibrium water content of ethylene glycol sodium alginate based hydrogel is always used for the environmental as well as medical applications. And here also the swelling equilibrium is also increases from pH is increases, swelling equilibrium is also increases. So that is the natures when we are going to look at for both the two things, 2.5 low concentration, 50 is higher concentration. This is a thermal analysis of both the 2.5 and 50 low concentration, high concentration. There is the decrease in the degradation rate, and also thermally high stable is always insisting. So these kind of thermal stable is always increases that due to the silver nanoparticle is always bounded inside the hydrogel network and enhance the thermal stability. And these are the same ADAX images of hydrogel that clearly explain the low concentration, high concentration distribution of silver nanoparticle within the hydrogel network is always processing, and here the maximum of silver is also observed. So these metals might have been present in a polymer network of SC hydrogel and silver nanocomposite. So this is the good evidence for the support of formation of silver nanoparticle within the hydrogel network, and optical absorption peak is also calculated by using some kind of formula. So that clearly shows the strong interaction is always takes place between the hydrogel as well as Ag plus ions. And this is the 10 images of silver nanoparticle. So from this silver image is also seen some images of nanoparticle, 2 nanometers, 20 nanometers, 50 nanometers, and 100 nanometers. All this range is always observed below the 100 nanometers. That clearly shows, and the spherical like shape is always observing nanoscale level within the size range from 2, 20, 50, 100 nanometers without any aggregations. So these distributions of silver nanocomposites and good evidence for the formation of some stabilization of silver nanoparticle within the hydrogel and carboxylate anion as well as the cations of the Ag plus ion. So both there is a interaction takes place, and clearly explain the phase center cube structure is also good evidence for the same images. And this is the XRD of silver nanocomposites and raw materials and parent hydrogel and low concentration, high concentration. So these type of intense peak was not observed for the particular SA hydrogel. So that is clearly explained as being exhibited. Any sharp peak is always more important parameters for the formation of silver nanoparticle, and highly dispersed silver nanoparticle is responsible for making silver nanocomposite. And this is the antibacterial activity of silver nanocomposites. We are going to I just focusing two negative, that is two bacteria such as gram bacteria and gram negative bacteria. So gram negative and gram bacteria shows some kind of values. So based on that, the formation of silver nanoparticles has been observed on the surface of the cell membrane. So from that, the Ag plus ion, already we are well known about that, diffused into the surface voids and cavities of hydrogel network is already discussed in the earlier sliders, and the interaction is always takes place. So that interaction, it enhances the bacterial activities. Here the ciprofloxacin is using as a standard values. And this is the cell viability of is done by using MTT assay test, and 3 MTT assay test is always used for 3T3 fibroblast cell line. and which is always used to evaluate the toxicity of the sample. So after the preparation of the compound or hydrogel or any material, your sample, it should be analyzed by using a cell viability MTT assay, because the maximum 25, minimum 25 to 500, and control cisplatin using as a control 100 platin is always observed, whereas in the case of minimum amount is 92% cell viability observed, both the two composites. So here a GBT value that is clearly explained, the ISO values, the cell viability is larger than 70% can be considered as showing the no cytotoxicity. And based on that GBT value and the comparison of ISO values, the my compound shows all the ranges is greater than 80%. So that clearly explained or well supported for the cytotoxicity is not present in my compound, and it's a more than 90% proliferation towards the 3,3T fibroblast line. So no toxicity natures, and based on the nature due to the interaction between hydrogel and silver nanoparticles. From that, the IC value is also well supported for the cell viability test. And this is the mechanism of biodegradation of hydrogel. So after the cytotoxicity is over, my compound is used to for the biodegradation stage. So that biodegradation test is just to take the sample, and it should be immersed into the two different type of things. And before you are going to discuss that one, we just look at the images, that is a biodegradation mechanism. And here the hydrogel network, already I told that he is having some cavities and holes, and network is also some of the hollowness. So based on that, definitely it absorbing some maximum amount of water molecule. Then after that, slowly degradation takes place due to bacterial action is takes place within the hydrogel network. So good example is cellulose is based on our rice. The good example, after second day, after first day, what will happen? Our rice, when it is present in the particular things, in freshly prepared rice is always shows some solid natures. Then after 12 hours, 24 hours, 1 day, 2 day, what will happen? The rice is undergoes degradation slowly because of the bacterial action. So same kind of action is also there for hydrogel, that is preparation of biodegradable hydrogels. Here with the biodegradation, so here I just focusing the two different type of methods, which is only used for the biodegradation studies only. For the first test is the soil burial test. So after preparation of hydrogel, the hydrogel as well as the nanocomposite, it should be immersed into the or poured into the particular good soil. It is present in my laboratory and nearest place. And what will happen? So it should be monitored every week, 7 days, 14 days, 21 days, 30 days. After the days, the time is increases, what will happen? The weight loss is always increases. So that clearly explain the weight loss, that clearly explain the degradation is occurs. So what will happen during the buried of some of the compound of soil in the particular gel, and so the nanocomposite, what will happen? So the nanocomposite already we are well known about. All the nanocomposites based on the sodium alginate is absorbing tendency is very high. So the soil containing some of the moisture, so that moisture it should be absorbed by some silver nitrate solution. So that is a silver based some composite. So when they increase the absorption, the more than 80% of weight loss is always absorbed. That is clearly explained. The expansion of hydrogel network, it has been clearly indicated that the synthesis silver nanocomposite hydrogel as well as the nanocomposite lower degradation weight loss than compared to pure AC hydrogel. So that is clearly explained. So when you are going to look at the time days for the second one, phosphate buffer solution, the second method is a phosphate buffer solution, and the phosphate buffer solution is preferred by a laboratory. And the college laboratory, they will provide some of the phosphate buffers tablets, and apart from that phosphate buffer solutions, I just focusing some different type of phosphate buffer solution. So based on that, the time duration is also increases, and the weight loss is also increases. Here what will happen? Already we are well known about that the anionic hydrogel, when it is immersed in the particular buffer solution, it absorbing tendency is also very high, because the anion hydrogel expansion and water tendency absorption is also very high at basic medium only. So there is the interactions carried out between the excess amount of silver ion and CO ions leads to decrease in the degradation rate, because when you are going to compare for the hydrogel as well as the nanocomposite shows low degradation when compared to soil burial test and phosphate buffer solution for the raw material. How it is conformed? So here we just focusing the low concentration, high concentration. There is a instruction, that is destruction or vanishing of some particular compounds. So that is clearly explained. The reasoning of lowering of weight loss is due to the greater interactions of Ag+ ion and also binding of anionic hydrogel network via electrostatic attraction is always make stronger. So there is changes of peaks also observed, and also anionic natures of hydrogel strongly bounded within the silver ion. Both the two things is strongly supported for the degradation of that is soil burial test. Whereas in the case of look at the IR spectra, FTIR spectra, that shows the PBS method, phosphate buffer method. Here the most amount of the peak is always shifting and appearance of mu peak is also observed. That compound well supported for the low degradation of silver nanocomposite hydrogel in acidic medium only. Whereas in the case of when that pH range is increases from 2 to 3, 4, 5 and etc. up to 10, the basic medium is always shows some higher things. So it is worth mentioning that greater degradation weight loss is always observed and for raw material such as parent hydrogel only. And this is the same images. After the degradation is over, the compound, the nanocomposite hydrogel is sent to the FTIR spectrum as well as the same images. So same images, the shows A and B and C and D. So AB is the low concentration of silver ion and B, CD is the high concentration of silver ion. That clearly explain the both the two nanocomposites shows some of the cavities and holes and some of the cleavage. So all the morphological changes and damages have been found to enhance with increasing the rate of biodegradation. That clearly explain the soil burial test is always lesser when compared to the phosphate buffer solution. However, there is a different type of concentration of metal ion is also present, and due to the breaking of silver nanocomposite hydrogel, the network is always very slow in the soil. Strong is very difficult and slow. And due to the causes of bacterial and fungal actions, also lower in the soil burial test. Whereas, however, in the case of phosphate buffer solution, there is a different type of mechanism is also there for swelling natures, biodegradations, all the things is always increase the rate of biodegradation. So based on the same kind of procedures, I also tried for diethylene glycol based hydrogel and triethylene glycol hydrogel based hydrogel. I just skip one to another. This is a schematic. There is a FTIR spectra for diethylene glycol based hydrogel and then triethylene glycol based hydrogel. So all the things is compared with the parent hydrogel and nanocomposites. That is clearly evidence for the formation of hydrogels. And here you just look at these diethylene glycol based hydrogel for semi images and TEM images of that is semi images of triethylene glycol based. So likewise, the left side shows some high concentration of silver nanoparticle bottom. This is the bottom side that is clearly explained. The silver nanoparticle is formed in the diethylene glycol base, shows some beautiful silver, that is a flower shaped structure. So that flower shaped structure, it always shows a beautiful flower star and like structure is always lead to enhancing the water molecules. Whereas in the case of triethylene molecules, that is shows some cabbage and sponge porous fibrous morphology. So that is also intake some more amount of water molecule within the hydrogel network. So both it is state the diethylene glycol, triethylene glycol, ethylene glycol, all the things shows some different type of semi images. So that clearly explain the formation of compound is also very feasible and also very simple. And here the diethylene glycol, triethylene glycol shows some of the needle and stick shape morphology is also observed. And here diethylene glycol some rectangle and biscuit structure, needle structure is also observed. So when you are going to compare for diethylene glycol is a pure compound, sponge and roughness is only takes place. Whereas in the case of increasing the concentration of silver by using same images, that shows some flower and other star structures. Whereas in the case of ST hydrogel, here we have some compound. So that compound shows some cavities. Whereas in the case of garbage structure and needle structure is always observed for the addition of triethylene glycol. And here the swelling is also clearly explained when you are going to look at the graph. We just look at the graph, diethylene glycol 2 compound, triethylene glycol 2 compound, 2 composites. Swelling is increases when the time is increases. So from that clearly explain when the time duration is increases by day as well the minutes, definitely the swelling equilibrium is also increases. That is clearly explained. Some cavities and holes is also present our preferred nanocomposites hydrogels. This is the equilibrium swelling studies is also done by using diethylene glycol and triethylene glycol. That's also good evidence for the things. When the pH is increases, swelling equilibrium is also increases, both the diethylene glycol, triethylene glycol. You just look at the graph that clearly explain the swelling equilibrium is always directly proportional to the pH. When the pH is increases, swelling equilibrium is also increases because of the anionic nature of hydrogel as well as the cationic solvent. So already I mentioned here, and more than 60% of water molecule present in our human body, and based on that, we're just focusing the equilibrium water content of diethylene glycol, triethylene glycol. Both it is having some promote water uptake capability. The maximum water content is attained at higher pH. And here the thermal analysis also clearly supported for the incorporation of diethylene glycol, triethylene glycol. Both it is having a lesser weight loss, and there is no weight loss for 50%. And here also less 50% is also observed. So that is shows the formation of strong nanocomposites. And here the same EDAX images for diethylene glycol, triethylene glycol shows some of the strong interaction is always occurs by silver nitrate particle between the hydroxyl group and anion hydrogels. So the well supported and confirmed the subsistence of silver nanoparticle within the hydrogel network. And these 10 images of diethylene glycol, triethylene glycol, both it shows some diethylene glycol, 10 meters, 10 nanometers, and 15 and 20 nanometers, 2 nanometers, 5 nanometers. All this range is always coming within the 100. That is very supported. And 10 nanometers, 20 nanometers, 500, both having some different type of space. So from that clearly explained, the formation of silver nanocomposite or embedded silver nanoparticles were spherical in shapes, but are confirmed by the formation of nanocomposites. And moreover, the formation of various rings has been supported the structure of FCC as well as the distributed nanoparticles. So from that, the XRD of silver nanocomposites also shows some of the formation of silver nanoparticles present in the hydrogel network. When you're going to compare for a raw material, that is parent hydrogel, as well as the composition of di and triethylene glycol based nanocomposites, both having some kind of peaks is always changes that clearly explain the formation of some nanoparticles. So already I told that based on that diethylene glycol, triethylene glycol is also sent to the antibacterial activity and clearly explain the some gram positive and gram negative bacteria is always possessing, and the good antibacterial activity is always well supported for the formation of nanoparticles within the cationic hydrogen network. And that is clearly explained the intranic interactions of silver nanoparticle within the hydrogel network is always shows a higher level. And here the cell viability, already I mentioned the GBT value for 2003 as well as the ISO value 1999. Both it shows some maximum IC value is 50%. There is no any kind of cytotoxicity. Based on that comments, there is a statement. The synthesized diethylene glycol, triethylene glycol based hydrogel shows more than 75%. That clearly explain that is considered as showing no cytotoxicity well observed in the particular cases of hydrogels. And biodegradation after the preparation of silver nanocomposites based on diethylene glycol, triethylene glycol, I just focusing the biodegradation by two methods. One is soil burial as well as the phosphate buffer solution. Both it is having some of the compound which is always incorporations of excess amount of silver ion always interact with the carboxylate ions to make them stronger, attain less weight is always observed. So from that, it is obviously shown that silver nanocomposite hydrogel has revealed lesser percentage weight loss than parent hydrogels. And how the hydrogel it should be supported for the biodegradation of Sp hydrogel, and FPI spectra is also more well supported for the degradations. And here the main reason of lowering weight loss is always explained due to the greater interaction of Ag+ ion and bind onto the anionic hydrogel network via electrostatic interactions may also stronger. So these kind of FPI spectra using soil burial test as per the phosphate buffer solution method. This is the phosphate buffer method. Both the shifting of appearance of new peak is also well supported for the low degradation of silver nanocomposite hydrogel in acidic medium. So these kind of evidence, for example, FPI spectra, both soil burial test, phosphate buffer solution test, both the ethylene glycol, diethylene glycol, triethylene glycol, nanocomposite, and semi images is a more important things our research, because before that yeah, only a few researchers they said about the degradations. So they are not mentioned particular about the degradations is studies by using FTR spectra as well as semi images. So, but in my cases, there is a diethylene glycol, triethylene glycol, ethylene glycol based hydrogen and then nanocomposite is the first method or first studies is always supported for the these semi images. FTR is also used for this kind of analysis. So based on the morphological changes and damages have also been found to increase the rate of degradation. However, after the degradation of low concentration of ethylene glycol and diethylene glycol, triethylene glycol is always insisting the formation of biodegradable natures. And based on that compound, after many applications of hydrogel is also there for drug delivery, food packaging, hygienic products, agriculture, scaffold, and biomedical. I just want to focusing wound dressing material environmental application, because I already told that whatever may be your product or your manufacture of fabric materials, your compound is always used for two peoples. One is our society and the another one is our human being. And based on that motto, I just want to focusing the wound entering dress material applications and environmental applications such as salt and dye removal. So after the successful preparation of hydrogel and then nanocomposites, I just sent a sample to the biomedical applications like wound healing applications. So based on that, just a minute. So environmental application is also carried out, such as removal of dye as well as salt. So here you just look at the cases which is always used for the case. Actually, I have selected many different type of concentration, but I just focusing a few flow chart regarding the removal of dye molecules. So you people, we are well known about acid chemistry. We are well known about that. Nowadays, the effluent molecules, that is effluent water as well as industrial water, that containing different type of dyes. One of the important dyes, methylene blue, otherwise called as diazine dye. It's a cationic dye. I already told it in the earlier slide, and the beginning slide I already told that our cationic dye or cationic salt is always more response via the interaction of anionic hydrogels, which is always cause the high bonds and nausea, vomiting, irritations. So methyl ammonia. And here more than 10,000 tons per year total dyes are consumed throughout the world, and less than 1 ppm in water is always undesirable. But nowadays we having some different type of tastes, and the people coming from that is the present in the particular area, Erode, Coimbatore, Tirupur, Ranipet, Ambur, and other Valaja district, they have some feeling of different type of taste of water is also available. So that clearly explains there is a different type of chemical incorporated within the groundwater. So that damage the acidic natures of environmental due to their high toxicity. And this cationic dye is always not been easily removed. And the removal is always based on the two mechanisms. The first one is a electrostatic interaction. I already told that in the beginning slides. And the hydrogel is always chosen for anionic nature, but when there is need some interaction, I just focusing the cationic charge. Methylene blue is a cation charge. So here the electrostatic interaction is takes place. How? Because of the hydrogen bonding interactions that is occurs between the neighboring group of CO group, functional group, CO minus functional group, and the hydrogel network and dye is a cation. So both the electrostatic interactions and this less hydrogen bonding interactions, both it is well supported for the removal of dyes. So this is the mechanism which is always behind that the formation of hydrogel. We already well known about that. The sodium alginate is a good example for the preparations of compound, which is always used for the compound, and it is a acrylic acid is also observed due to the basic of hydrogen bond natures, and finally the methylene blue is also used for the preparations of hydrogel network, and based on that CO minus group is able to attract cationic dye. So this kind of dye is always possessing and easily attract nature of chemical. So that nature of chemical is most important before you are going to choose any kind of effluent water treatment as well as the normal things. So there is need some idea. So that idea is always more important. When we are going to look at the idea, we people, we are trying to many different type of applications, such as a minimum amount of material which is used for both environmental as well as medical applications. So after the adsorption is over, what will happen in the desorption? The look at the side, the right side, desorption which takes place lower pH, whereas absorption takes place higher pH. So after the preparation of hydrogel as well as the nanocomposite, it should be poured into the particular water that containing methylene blue. What will happen? The absorption takes place at higher pH. So the same pH after the absorption is over, the definitely the hydrogel as well as nanocomposite the containing more amount of dye that shows some of the color. Just look at the blue color. That is a dry hydrogel and swollen hydrogel and absorption of methylene blue. All this shows some kind of absorption takes place, and it always shows some lower desorption takes place in the lower pH value. So based on the same kind of principle, I just focusing on mono di trivalent ion. So because the majority of the World Series problem is aggressive today life, because health is always caused in the environmental pollutions and caused heavy metal ions like cadmium, chromium, iron, cobalt, nickel. All the things, other effects also take place due to their bioaccumulation in living cells, that is always acting as a toxic natures and maybe carcinogenic and non-biodegradable is also available. Because the environmental role is also very important parameters, and based on the hydrogel is also more important parameters and more important material which is widely used for the high water intake ability, high water absorption tendency is also very high. So based on that, the salt removal tendency is also carried out by different type of cation anions interactions. And the second, one more wound healing preparations, and almost today my guide is also mentioning wound healing is the gradual restorations of injured tissues, which is reimbursement of the dermis of the repaired tissues. So you people, you must be just understand what I'm showing here. The injury which is always happen, torn, broken, or cut off, any different type. But the drawbacks, insufficient swelling ability. Our wound is insufficient swelling ability. The water retention capacity is also need. So based on the property and based on the problem, I just to overcome such setbacks, hydrogel have chosen as a effective biomaterial due to higher bioadhesive natures in sodium alginate and high swelling natures in sodium alginate, and wound healing tendency is also there for sodium alginate based hydrogel. So this hydrogel dressing is always provide good and better healing effect compared to other. So this is the in vivo wound healing. After the preparation of hydrogel as well as the nanocomposites, my hydrogel is always using for the in vivo rat model. So that is a promising with improved physical properties such as swelling. The rate of degradation with satisfying in vitro cytotoxicity is also supported. But here, the in vivo wound healing studies is also done by using the simple scheme that is represented. Hydrogel is poured day one rat model, albino rat is also chosen. Here already you are well known about that. The hydrogel having some antibacterial activity, cytotoxicity assay is also good. And based on that, after the 9th day, the albino rat is completely cured and completely the burn is disappears. That well supported and is also published in carbonated polymers. And here this is the in vivo wound healing is also how it is done with a different type of days. So that shows some incision method have been adopted for wound healing effect. Wilster albino rat. So 6 Wilster albino rat and 4 models also takes. And this method is nothing but incision in vivo method. And this hydrogel is always significant role for improvement of our wound healing within 9 days. When you are going to compare for other peoples, they are already mentioned or they are given some report regarding the 15 days, 20 days, 30 days. And actually, what will happen during the burning or cutting of any kind of wound is happen in our human being. It will take minimum 10 days to undergo further purifications. Whereas in the case, the entire study of the wound healing is always compared with the market formulation. So the market level available in the sulfadiazine is a medicine and it's a ointment, and it shows some minimum level when compared to the so faster, better epithelialization and granulation of wound is always observed in my compound. I will explain with the support of 0 day, and the images shows some albino rat model. So this albino rat model, 6 centimeter, that is cut for different type of days, 0 days. The first thing is a wound heal. Left side, you just look at 0, 0, that is a wound healing, 0 day, 5th day, and 9th day. The wound only, they are having some of the blood is also there. Whereas in the case of second center part, wound plus standard. What is standard? Here the sulfadiazine ointment is available in the market. That is a brown color ointment. It is widely used for wound healing materials. So which is also using as a standard. Then after that, the final third one, wound plus hydrogel. Here the 0 days, what will happen? And 5th day, what will happen? And the 9th day, what will happen? So here we can easily observe the more amount of wound is always completely cured, and it shows some better epithelialization as well as the complete cure of burn is always observed at 9th day. So that it clearly explains the cell, that is epithelialization and granulation all occurs in the 9th day. That will show some of the wound hydrogels. So up to this one, I can stop a small part of research work. And recently, we have some publishing in some kind of hydrogels in the carbohydrate polymers and RSC here. Different type of ketogenic acid is also using, and indole 3 acetic acid is also used for the preparation of different type of hydrogel. And recently, we also used it for aniline based some hydrogel compounds, and it shows some bacterial and magnetic activity, antifungal activity. And here we have some functional modification of some of the compound is also chosen, and these are the few compound. Apart from that, we also tried for many different type of compound with the self moto and self supporting. So you people, you must be understand when you're going to look at your research, you people, you must be think about the your compound. It may be used with our society or not, you fix it, right? And further the conclusions, based on that all the things is a renewable sources, and through the reaction is a simple and convenient method. We are only producing maximum 4 hours is enough for the preparation of nanocomposites and greener approach method. Throughout the reaction, the water acts as a solvent, and mint leaf extract solution is always used for the reducing agent. And the eco-friendly polyol saccharide is always used for the non-toxic cross linker, and solvent is not used for the reaction. So based on that polysaccharide and the pH sensitive hydrogel and the silver nanocomposite hydrogel is always a greater opening for our future industrial and biological applications by using a greener approach method. Thank you. Thank you, sir.
Thank you, Professor. Professor Sudarshan?
Yes, sir. Yes, sir.
Okay, thank you, Professor.
Thank you, sir.
Please wait for 2 seconds, Professor.
I thank our chief guest, Dr. S. Sudarshan. He explained clearly about smart hydrogels as multifunctional biomimetic system, applications of hydrogel classification and the signification of hydrogels, classification of monomer-based origin. He explained about hydrogel fabrication, and he clearly explained about how pH-sensitive polymer hydrogel is used, sodium alignment scope, fabrication of silver biocomposites hydrogels, mechanism of biodegradable of SCN hydrogels. Thank you for your adorable presentation, sir. And once again, thank you, sir.
So Govind Raj, Dr. Govind.
Professor?
Yeah.
Okay, thank you, Professor.
Thank you, sir. Thank you for your opportunity, and thanks again, once again, for our management and Department of Chemistry. Thank you, sir.
Okay, thank you, Professor.
Thank you. Govind,
Yes, Professor.
முடிச்சுக்கிட்டுமா?
Okay, okay, Professor.
Is there any queries?
Okay, no queries, Professor.
Okay, sir. Thank you. Thank you.
Okay, thank you, Professor.
Now I like to invite Ms. G. Vimala, Assistant Professor, Department of Chemistry, Sri Vidya Mandir Arts and Science College, to honor and introduce our chief guest.
Sound very fine, sir. Professor.
Hello, sir. Good morning, sir.
Voice is audible, Professor.
Hey, sir. I listen. Yeah, I got it.
I welcome everyone and good morning to one and all. I would like to invite our chief guest, Dr. Mani Govindasamy, Research Assistant Professor, Department of Material and Mineral Resources, Engineering, National Taipei University of Technology, Taiwan. He completed his graduate at St. Joseph College, Bharatidasan University, Tiruchirappalli, Tamil Nadu, India. He completed his master's degree at Bishop Heber College, Bharatidasan University, Tiruchirappalli, Tamil Nadu, India. He completed his PhD at National Taipei University of Technology, Taiwan in the year 2018. He was working as project assistant in Department of Chemistry, Bishop Heber College, Tiruchirappalli in the year 2014 to 15. He was working as project associate in the Department of Energy and Optoelectronic Material, National Taipei University of Technology, Taiwan. In the year 2015 to 17, he was working as postdoctoral faculty in Department of Biochemistry and Biotechnology, National Taipei University of Technology, Taiwan in the year 2018 to 19. Presently, he is working as Research Assistant Professor in Department of Material and Mineral Resources Engineering, National Taipei University of Technology, Taipei, Taiwan. He completed the Large Research Project MOST in the year 2015 to 18 and a Special Research Project MOST in the year 2019 to 20. He has published more than 18 journals in international level. His citation score more than 250, I-10 index more than 16, and H index more than 30. He guided 10 master students and 5 internship students and 6 PhD scholars in National Taipei University of Technology, Taiwan. He has been working as a team leader and establishing various research collaboration with various research institutions, Japan, India, and South Korea. Now, he is working on sensor and biosensor, photo degradation, energy conversion, oxidation reduction reaction, DSSC, and energy storage device supercapacitor application. He received Outstanding Research Award from CTCI Foundation, Science and Technology, Taiwan in the year 2018. He received Taipei Tech Scholarship for International Graduate Students, Taiwan in the year 2015 to 18. He received International Student Special Scholarship and Sunshine Year-End Scholarship from National Taipei University of Technology in the year 2016 and 2017. He received Best Research Professor Award at National Taipei University of Technology, Taiwan in the year 2019. His areas of research interest: electrochemical, biosensor, material science, electrochemistry, nanocomposites, electrochemical analysis, nanotechnology, catalysis, modified electrochemical methods, cyclic voltammetry, supercapacitor, lithium-ion battery, electroanalytical chemistry, electroanalysis, amperometry, potentiometry, electrochemical instrument, stripping voltammetry, electrodeposition, electrocatalysis, screen printing, bioelectronics, impedance analysis, energy storage material, photocatalyst, semiconductor material, and water splitting reactions. Concluding, I wish Professor Dr. Mani Govindan makes successful and enlightening this conference. Thank you.
Professor.
Okay, Professor, I can start. You can start presentation. Hello. Hello, Professor. Can I start my presentation? Hello.
Professor, visible your slides, Professor.
I already shared, sir. Please check. Hello, sir. Hello. Hello, sir.
Sir, your screen is visible, Professor. Let's start, Professor.
Okay, can I start?
Yes, Professor.
Okay, okay.
Okay, thank you, Professor.
Good afternoon, professors and students. Hello, sir. Got it? My talk? Hello, sir.
Professor?
Are you listening?
Yes, Professor.
Okay, okay, okay.
Audible, Professor. Okay, thank you, Professor.
Okay. Good afternoon, professors and dear students. Now I discuss with my my previous research and the current research based on the healthcare devices based on the electrochemical sensors using polymers and 2D layered nanocomposites. I'm working as a research assistant professor in National Tibet University of Technology. Once again, thank you for previous introduction about my previous introduction section. Thank you. Introduction. In this section, I introduced food safety analysis, and then clinical analysis, detection of methods and its advantages, and then two-dimensional materials based properties, and then biopolymers. And then aim and scope of the work is food toxic chemicals reduction with variation with different food samples, determination of bio analytes in biological samples, and then continuously the resultant discussion of two sections. One, the enzymatic biosensor, another one is non-enzymatic biosensor with different polymer based composites. The overview, in my laboratory, we are working in a different kind of research area based on the electrochemistry applications through the nanotechnology materials, nanomaterials. For application aspect, we are focusing food safety analysis and drug analysis, and then the water analysis based on the food and health based analysis. First of all, the food safety biggest issue in the current trending, because based on the population in current world, they are using different kind of pesticides, antibiotics, and then preservative chemicals due to the increase in the food crops, and then the increase in the food products, and then food long time preserving the food. So they are using many kind of toxic chemicals to save the long time preservative foods. That's why the particular limit of the toxic for the particular limit of chemicals, it's okay. But other than, if you increase the high concentration of toxic chemicals in the food, it will affect the human health. So we need to find out the concentration of the toxic chemical in food. Moreover, the pesticide. The pesticide is one of the major issues in the food safety department, because the current trending methyl parathion based on the organophosphates they are using in agriculture department. It is also used for avoiding the pest, but unfortunately they are using the high concentration of pesticides, it affects human health. We will take the food orally, then it affects human body. So that's why we need to optimize we need to find out the concentration of pesticides in the food sample. And another thing, the antibiotics. Antibiotics, one of the important in our life, but unfortunately, the same antibiotic it affects human body also, because the animals, for example, the cow, the animals, the peoples, they are using different kind of antibiotics in cow to produce the milk, increase the milk production. But unfortunately, if increase the concentration of chlorofenicol, it into the milk, then it affects the human body, and then mostly it affects the children. So we need to find out the concentration of chlorofenicol or any toxic chemical. These are the antibiotics. We need to find out the concentrations in milk directly. And then food analysis, the similar way, the food analysis, the major issues food additive and then feed additive. Feed additive means it's like the chicken. Recently, many kind of antibiotics they are using to increase the weight gaining of chicken. They are using a lot of antibiotics. It's highly affected in human body. Similarly, food additive, same like the chlorofenicol. Chlorofenicol using as a preservative in honey. In recent literatures in India, they are using a lot of preservative chemicals in honey and then milk. Then preservative chemicals is the major issues, particularly meat samples. The meat samples, they are using the sodium nitrite, beta-hydroxyanisole, and butylated hydroxytoluene, propyl galatate. These kind of the antibiotics and the preservative chemicals they are using to the particular country. They allow the low concentration of preservatives because they need to save food particular time, but unfortunately they are using the lot of preservative chemicals in the meat samples. It's highly affected human body. That's why we are focusing the reduction of these kind of chemicals in the food samples. Then the clinical analysis. The clinical analysis, the three kind of one is the oxidative reactive oxygen species, and then neurotransmitters and reactive nitrogen species. These are the major clinical analysis in our body. If any diseases we are affected, these kind of any one will be increased or decreased in our body. It will be these kind of analysis changes only our body affects different kind of disease. For example, the reactive oxygen and nitrogen species means it will be change the human metabolism, like antioxidants will be changes in our body. It will affect the human health directly. It affects the DNA cell, DNA unit, and then it will be create the different kind of toxic effect in human, in particularly cancer. Also, based on the antioxidant and the anti-nitrogen species increases in our body, it will be create the cancer tumors. And other than the the oxidative stress in our recent life, many people affect their stress because the increasing the concentration of hydrogen peroxide, these hydrogen peroxide and superoxide ion and hydroxide radicals and peroxide. These are the ions are the reactive oxygen species. If affected reactive oxygen stress, it will be increased, and also we also affect the different kind of human issues. So similar like reactive nitrogen species also, 3-nitrotyrosine and these kind of nitrogen based reactive nitrogen species. And then the neurotransmitters. Another kind of is neurotransmitter, one of the main biological functions. The dopamine, serotonin, adrenaline, these kind of the neurotransmitters in our main functions. For example, the brain functions and then the nervous functions. Everything is based on the concentration of neurotransmitters. If the neurotransmitters, the concentration will be changed. Low. If you reduce the dopamine concentration in our body, it will be affect very serious health issues. For example, the above 50 age people, they affect the different kind of disease. Its main reason dopamine concentration will be decreased or sometimes it will be increased. So we need to find out the concentration of dopamine in our body, similar like serotonin and adrenaline. These are the important neurotransmitters in our body. The main disease in neurotransmitter based is Parkinson's disease. It's lack of the adrenaline concentration and lack of dopamine concentration in our body. It will be affect very serious effect. Sometimes it will go for death also. Generally, the analytical methods, currently the analytical methods using calorimetric assay and then chemiluminescence and HPLC fluorescence methods. Sometimes recently we are developing the direct electrochemical sensors. Compared to other previous methods, the ELISA methods, and these are the methods are very these also is effective, but unfortunately these are the very costly, and then it takes too long time. If you give the samples, it takes 2 to 3 days time to get the results, and then it's more expensive. But my research group, they are focusing, we are focusing the direct electrochemical sensors for portable, and then it is very convenient to take to other place. It's very easy, and then it's electrochemical signals, very easily to find out the electrochemical signal, and then real-time analysis very feasible. It's very less samples. For example, the urine sample or blood serum samples or any other the biological fluid, very less samples we can find out the concentration of the analyte. So that's why we are choosing the direct electrochemical sensors. And then the electrochemical sensors, we are using different kind of methods. Mostly in our group, we are using the drop spacing method. It's very simple. For example, we are using the multi-conventional electrode. It's the screen printed carbon electrode, and then we are making the composite, polymer-based composite, and then drop paste the surface area, and then dry, then wash, then using the electrochemical setup for anode, cathode, and the reference electrode. Then we are using biological sensor pH7 as the electrolyte. Then we can go for the potentiometric, and then potentiometric sensors and volumetric sensor also. So this is the electrochemical methods and its advantages. We are using the cyclic voltammetry, the CV method, and then the different pulse voltammetry DPV, and amperometric IT method, and electrochemical impedance spectroscopy, EAS method. Then the major advantages, previously already give the details. For example, the eye sensitive, we can find out the eye sensitive and fast reduction, and then electrochemical fabrication is very simple compared to the other methods to the operate the instrument, and then the low cost compared to the HPLC, and then fluorescence methods, and then the ELISA methods. These kind of methods, the electrochemical sensor method is low cost and portable. We can easily to take to one place to other place, and then it take very less time compared to the other methods. It takes just 10 to 15 minutes. We will get a good result. And then the working flow of working flow. For example, first we can design the work, and then the synthesis, the nanomaterials, and then characterization, and then for moving for electrochemical testing, and then the selectivity analysis of the material, and then real sample analysis for real-time evaluation. Then the 2D layered nanocomposite. Mainly we are focusing 2D layered nanocomposite, molybdenum sulfide, tungsten sulfide, molybdenum selenide, tungsten selenide, these kind of 2D layered materials, because these are the thermal conductive materials and large surface area, and then the mechanical flexibility, and then the transparent, for example, graphene. Graphene is one kind of transparent electrochemical material, and then it's carrying high charge mobility to electron transfer one place to another place. And then preparation of the electrochemical device. We are focusing different kind of sensors. For example, modified electrode and modified electrode using the glassy carbon electrode and screen printed carbon electrode, molecular imprinted MIP electrodes, and then non-invasive sensors and metal organic framework. These are the sensors. These are the materials we are using to different applications for electrochemical detection of biological analytes. And then currently we are focusing smartphone based device for on-set food safety testing. The signal is converted to easily to the mobile phone. It's very convenient to check the signals for biological analytes. And then the first part, I'm focusing the reduced graphene oxide nanoribbon with chitosan biopolymer, and then the myoglobin. Myoglobin is one kind of enzyme. It is one we are using here the selective determination of the hydrogen peroxide and nitride. The hydrogen peroxide is oxidative biomarker, and also nitride is food safety. For example, nitride mostly using in beef, and mostly they are using beef, many kind of food. For example, one country to another country, they export the food samples. For example, food products, beef and lamb, this kind of foods. They are using a lot of preservatives, in particularly nitride. Nitride is one of the major issue in the food safety department. So that's why we are find out we are making one kind of device to find out the nitrate concentration in the food samples. Here we are using chitosan. Chitosan is one kind of the biopolymer. It's easily prepared material, and then reduced graphene oxide nanoribbon. It's similar like graphene, but its shape is like nanoribbon shape. So that's why we called here the nanoribbon. And then it's synthesis from the multi-walled carbon nanotube. And then the selectivity aspect, we are using the myoglobin. It's one kind of enzyme. And then for synthesis procedure, the reduced graphene oxide we synthesis from isothermal method, and then chitosan biopolymer, we can add the sonicated method, and then we can make the composite, the reduced graphene oxide nanoribbon, RGYMR, and then chitosan we can combine within 15 minutes to make the composite, and then coated on the glassy carbon electrode, and then we can make the myoglobin concentration. Then we can add to drop case the similar method to make the electrode. To finally we get the graphene reduced graphene oxide chitosan at myoglobin based on the glassy carbon electrode. Then we can finally detect the hydrogen peroxide and then nitride. This is the electrochemical studies of composites. First of all, first one is the multi-walled carbon nanotube. It's commercial one from the Sigma Alpich. Then we can go for the to prepare the isothermal method. We can get the nanoribbon shape to separate the tubes. To will we get the ribbon shape. Then it's one kind of matrix. So the multi-walled carbon tube is converted to reduced graphene oxide nanoribbon. It's one kind of matrix. Then we can add the C is the ASM images of chitosan with matrix. That means after the process, we will get the good morphological like this porous material. It's not nano, it's porous material. And then we can get the final composite. Because why we are using the chitosan means it have the porosity it easily absorb the easily absorb the myoglobin. Most of the biosensors, they need biocompatible material. So here the cytosine, the one main, it's one kind of main role of the electrode material here. Then we are focusing the confirmation of the immobilization. The red color one is the immobilization, and then without this one is without immobilization of myoglobin. When adding the myoglobin, the current resistance will be increased. That means the enzyme easily immobilized with the reduced graphene oxide and cytosine biopolymer. We can find out, and similarly the current also increased based on the we easily find out the immobilization through the electrochemical studies. And then the electrochemical detection of H2O2. It's first one is the electrochemical detection of H2O2. The other control electrode, compared to the composite material, its current will be good. And then there's different concentrations, 10 to 16 micromolar, and then the corresponding standard analysis. And then this one is amperometric analysis. We can find out the 80 nanomolar too, and then high concentration is more than 1500 micromolar. It will be good, the wide linear range. And then we also analyze the selectivity aspect for the biological analyze, uric acid, aspartic acid, and then folic acid. This kind of biological analyte we can add the simultaneously, but it's affected very less than 5% of interference. So compared to the control electrodes and the interference, H2O2 detection is very feasible in this material due to the cytosine and reduced graphene oxide. And then electrochemical detection of nitride. Nitrides, it also food preservative. So here we are using the nitride to oxidation aspect. To here we will get the good current response compared to the other control electrode. And then the concentrations here we are using the up to 30 micromolar in the CV response, and then scan rate, and then similar way the amperometric analysis to 0.1 nanomolar to the high concentration is up to 1200, more than 1200 micromolar. It will be get good current. Similar way the selectivity study also we done. Then the real sample analysis. Every electrochemical sensor aspect, we can focus the real sample analysis is very important because the real-time analysis, we are focusing the real-time analysis. Here we are focusing the H2O2 is in the contact lens solution, and then the nitrate in bead sample. So we can prepare the bead sample from the collected from the market. Then we can take the samples and prepare the extract, and then we can go for the electrochemical aspect. And then the second part, the simultaneous detection of neurotransmitters and the dopamine and uric acid. In the uric acid, one of the important biological function in our body. If uric acid will be increased in our body, our body will be affect very serious effects, in particularly kidney failure. So we can find out the uric acid based on the electrochemical method through the biological property based polymers like polyaniline. Here we are using the polyaniline and activated carbon. CETA, we are using the structure based material. Then here we are preparing the surfactants. The CETA is one kind of surfactant here using, and then simultaneously detection the dopamine and uric acid. Here the characterization of the composite. First one, these are the polyaniline. First one is polyaniline with activated carbon. The second one is only the activated carbon. This one, the only these are the only the PANI, that means the polyaniline. It's TM image, and then TM images of the activated carbon. This image is good compared to this one, because this one is the rough surface. It's compared to the only activated carbon. The composites have the rough surface, that means the electrochemically active surfaces and cavity sites. So it's more good compared to the without polymer. Here we are focusing the deduction of dopamine and uric acid based on the electrochemical method. A is the uric acid and dopamine deduction, and then these also the control A and B is control electrode, and then this one is composite. Compared to A and B, it's very good performance and very sharp peak. We got the sharp peak. And then and one more thing, the individual analysis, and then go for the simultaneous deduction, because in our body have dopamine, uric acid, hydrogen peroxide. These are the simultaneously we will get it's more good. So here the dopamine and the uric acid we will analyze the simultaneously. Then we get dopamine and uric acid peak separately and near potential range. So compared to the bear and the other controller without PANI, it's very less peak current, and also the peak to peak separation very less. But if you add the PANI, then it will get the good current response, and also peak to peak separation also is good. Here the simultaneous reduction of the DA and uric acid with increasing the concentration, because sometimes some electrode increasing the concentration, the current will be reduced. That means the fouling effect. But here we can check the fouling effect. Increasing the current particular range, it will be simultaneously it's increased. So if that material have anti-fouling effect. So, and also this one is the electrochemical, the cyclic voltammetry method, and then we find out the DPV method also. We will get the good linear range. And then the table 2, deduction of DA and uric acid in the real sample analysis, CTAP, the PANI. It's the real sample analysis is the uric acid detect in urine samples, and human serum is detect the dopamine concentrations, and the rat brain samples, and then the dopamine injection. We can get the dopamine injection from the pharmaceuticals. Then we analyze that directly. Our sensor is how the sensor is working. The recovery is our sensor is accurately working or not. We can find out through the real sample analysis. Then the clinical analysis results: the hydrogen peroxide, nitric acid, and then dopamine and uric acid. Here the 4 kind of sensors we are using, and then the different kind of materials. First one is chitosan, a biopolymer based nanocomposite for detection of hydrogen peroxide in real sample is contact lens. And second one is reduced graphene oxide nanoribbon, chitosan biopolymer, and myoglobin as the selective enzyme. Similar way, here the real sample is B sample, the food samples. And then the next one is polyaniline based nanocomposite. It's dopamine detection for rat brain in rat brain serum, and dopamine injection based on the pharmaceutical samples. And then the uric acid also the similar the CTAP and PANI activated carbon deduction in human blood serum and then urine samples. Recently we published any article. Some of the articles here I given. The food safety department, we are also working in the reduction of chlorophenicol. It's highly toxic in food department. For example, chlorophenicol mostly using in milk preservative and then the honey. So here we are focusing the copper sulfide decorated reduced graphene oxide nanocomposite for reduction of antibiotic in milk samples. So we are preparing the sonochemical method to get the nanocomposite, and then we can analyze the electrochemical method, and then these are the mechanisms. The chlorophenicol, it goes the 4-electron transfer reaction, and then it goes the 2-electron transfer reverse process. For example, the oxidation, and then this one is oxidation, and then the reduction. So on morphology also we analyze is the sphere-like nanosphere-like nanoparticle decorated on the reduced graphene oxide nanosheet. And then the novel synthesis of the tungsten carbide nanosheet. We prepared the different isothermal method, and then we can analyze the mercury concentration in fish samples. The recent report, the fish products, they it have mercury content. It's highly toxic in human body. It's also affect the it causing the death also. So based on the literature, are finding the nanomaterial to detect the mercury concentration in fish sample. Another one is the novel electrochemical sensor for detection of DNA damaging biomarker. It's 8-hydroxy2. Based on this biomolecule, it will be affect in our body. For example, increasing the 8-hydroxy deoxygenone, our body will be affect to sometimes it's quite cancer also. So we can prepare the nanomaterial. Here I prepared zinc oxide nanomaterial with graphene oxide nanosheet. Modified electrode is the glassy carbon electrode. Finally, we get the composite conforming the morphological analysis for SEM and then the TM analysis. These are the zinc oxide flower-like shape. It's also sheet, and then the overall combining the graphene oxide, it's also sheet-like structure. It also the oxidation, 2-electron and 2-proton transfer, the mechanism. And then the synthesis of bismuth telluride nanocomposite. This also recently we prepared this electrode for electrochemical reduction of biomolecules in biological samples. The epiprene, previously I told you that the epiprene is one kind of neurotransmitter. Its biological function. So we can find out the concentration of epiprene. It's also useful for clinical analysis. Here I will prepare the synthesis of bismuth telluride. It's one kind of telluride-based nanomaterial. And then we combine with the graphene oxide. These are the work we are using any one the matrix, graphene oxide, reduced graphene oxide, or CNT, or any kind of matrix with metal oxide or metal sulfide, this kind of electrocatalytic material, then combine to make the composite, then finally go for electrochemical application. This is the electrochemical. Finally, first we get the composite, then we can go for the calcination aspect. Here the SEM images of bismuth telluride, and then the composite with the graphene oxide. Here, see the graphene oxide is very. We can get we can see that very clearly inside the nanoparticle. We can easily find out the TM image, the nanoparticle inside that, and then it's covered and entrobe the nanomaterial to get the composite. So this interaction more useful for the electrocatalytic applications, and then the here we can find out the element in the composite, and then electrochemical determination of epiprene by the DPV method. Here the we can compare to the control electrode bar GC and then metal oxide. Composites have the good current response due to the electrostatic interaction of the nanomaterials. Then the epiprene is 2-electron 2-proton redox coupled redox, and then we can get the quinone mechanism. Then the DPV method. Another article, the effect of sonochemical approach, and it used the this kind of bismuth sulfide and graphitic carbonitride as the modified electrode for electrocatalytic detection of antibiotic in foodstuff. It means the similar way the previous article also the chlorophyll sensor. Similar way, we are using the milk as the real sample and milk and honey. We prepare the nanomaterial for sonochemical method to get the unique shape like the core shell shape, and then we can focus for electrochemical detection of the CAP. The next one is we also working in flexible carbon clad for energy applications. We are working with different area, electrochemical sensors and supercapacitors, photocatalytic degradation. This is another article for supercapacitor based research. Here we are preparing the binary metal sulfide, and then we can make it in carbon clad and then go for the supercapacitor application. We got the good response based on the material and flexible. In future, we are working in flexible based electrochemical sensors and also the energy based devices. This is in future work. We also I told you that we are working in the flexible electrochemical devices, for example, wearable sensors to find out the biological analytes, to easily get the signals from the through the Bluetooth and get the results in mobile phone. So it's convenient to get the results for biological function, the sweat from the sweat, and then urine sample or blood serum samples like that. So we are preparing, we are focusing the wearable based electrochemical sensors. And then this is my research profile. Published in my research group, through my research group, published more than 80 plus articles. So still I'm working in different kind of area, the electrochemical sensors, and then the collaboration works also. And also thank you, the final section, the thank you, organizing the conference. In particularly, I got information from Dr. Raja, this conference, thank you, and also the organized committee, and then the principal and department, other organizers, thank you so much. And finally, I thank my department and my university for giving the portion to the research. Thank you. Finally, I thank the students, the audience, the professors, and other technicians of the conference. Thank you.
Thank you, Professor.
Yeah, thank you. Any other questions from the audience side?
No questions, Professor. Stay for 2 seconds, Professor.
Okay.
Okay.
I thank to our chief guest, Dr. Mani Govindasamy. He explained clearly about healthcare device-based electrochemical biosensors using polymer and 2D layered nanocomposites and pesticides in fruits. Antibiotic food analyzers. He clearly explained about clinical analyzers as reactive oxygen and nitrogen species. Then he clearly explained about neurotransmitter and the types of neurotransmitters. And he explained the aim of neurotransmitter sensors, general analyticals of methods and its advantages. And he explained the 2D layered nanomaterials and properties. And he explained the characterization studies of composites, enzyme activity, electrochemical detection of H2O2, and clearly explained about characteristic studies of composites clinical analysis. Thank you for your mesmerizing presentation, sir. Once again, thank you, sir.
Thank you. Thank you.
Thank you, Professor.
Thank you, sir. Thank you. Thanks so much.
Yes. Professor?
Yes, sir. Voice கேக்குதுங்களா சார்?
Yes, audible, sir.
Audible, sir.
Okay. Screen visible இருக்குங்க சார். சார் screen share பண்ணிடுங்க.
Okay, slide share பண்ணுங்க. You can.
சார் ஆல்ரெடி ஷேர் பண்ணியாச்சுங்க சார். ஸ்கிரீன் தெரியுதுங்களா சார் உங்களுக்கு?
Sir, just 2 seconds, sir.
ஓகே ஓகே.
Chemistry can be good and a bad thing. Chemistry is good when you make love with it. Chemistry is bad when you make bad with it. And good afternoon to all present here. Let me start the afternoon session of second day conference. Now I request Dr. R. Dayanandan, Assistant Professor, Department of Chemistry, Vidyamandar Arts and Science College, Puthangarai, to honor and introduce our chief guest.
Good afternoon to one and all present here. I am proud to introduce our today's chief guest, Dr. S. Satyan, postdoctoral fellow, Institute for Energy Research, Jiangsu University, Shenzhen, China. Professor has done his BSc Chemistry in Government Arts and Science College, Coimbatore, 2011. He done his MSc Chemistry at Sri Ramakrishna Mission Vidyalaya College of Arts and Science, Coimbatore, 2011 and 13. Professor has completed his doctoral in chemistry at VIT University, Vellore during the year 2013 and 2017. His professional experience, the professor has been as a project scientist with Dr. Rajiv Kumar Gupta, Department of Chemical Engineering, Indian Institute of Technology, Kanpur, during 2017. And during 2017 and 19, he is a Serb National Postdoctoral Fellow with Dr. Anand Singh. And he is a postdoctoral fellow during 2019 with Professor Minchen Institute for Energy Research, Jiangsu University, Jiangxing, China. Professor has published research publications of 15 articles in the field of solar cell applications, corrosion inhibitor, carbazole-based polymer in a reputed journals of Royal Society of Chemistry, American Chemical Society, Tetrahedron Letters, Materials Today, Energy, Materials Today's Chemistry, Journal of Alloys and Compounds, Applied Energy Materials, and Nano Energy. He has published the book chapters, 5 book chapters in Elsewhere, Material Science and Technology, Nanomaterials for Green Energy, and Springer Proceedings, etc. Professor has attended many international conferences, symposium at Chandigarh, China, Tiruchengodu, VIT University, and he attended a national workshop at sixth workshop at VIT Vellore. His academic profession is research interest in design and synthesis of polymer and small molecules, classification of polymers and its characterization, perovskite solar cell fabrication, isolation of compounds with using chromatographic techniques. Such a research person is waiting to give you a wonderful lecture for you students. So use this session and make the session successful. Thank you.
So thank you, sir. Thank you giving nice introduction and detailed introduction about me, sir. So the screen is visible, sir. Hello. Hello. Sir. Hello. Hello, sir. Hello.
Sorry, sir.
Sir, my voice is audible, sir?
Yes, sir. Audible, sir.
And the screen also visible, sir?
Yes, sir. Okay, sir.
Okay, sir. Now it's moving, sir?
Yes, sir. You can start.
Okay, sir. Okay. Thank you, sir. Thank you, sir. So thank you, Professor, giving nice introduction and a detailed introduction about me. Myself, G. Satyan, doing postdoc in Jiangsu University, China. Today, I am going to present organic materials in perovskite solar cell applications. In this topic, I am going to cover what is the solar cell and then what type of solar cells are available, and then why solar cells are important compared to other technology, and then what type of organic material has been used for the solar cell application technology, and then some of the related work I have done for solar cell application. So I want to give some of my work also example for this work, and then followed by the conclusion, sir. So everyone knows about what is mean solar cell. Solar cell nothing but which electrical device that convert light energy into electrical energy by the photovoltaic effect. As we know, all of in our home we have the installed in roof tower solar panel. The solar panel consists of a device. The device consists of two different types of material. One is the N-type semiconductors, another is the P-type semiconductors. As we know what happened inside, when sunlight strike on our panel, the panel try to absorb the photons. Photons, we know which photon having the bundles of light, having the bundles of photons. The photons what absorb the semiconductors, it's try to separate. One is the hole, another is the electron. So after the electron can be separated using circuit, that is the electron called as the solar cells. So why we need solar cell compared to other technology? Because solar cell is we are using some other technology to produce energy. For example, fossil fuel and the nuclear. This kind of thing we are using to produce the energy. Due to this one, we are getting a lot of global warming, and then every year increasing 1 degree of Celsius. But still, a lot of villages don't have proper electricity, and due to in our country, our side also daily 2 to 3 hours power cut will be there, and then the fossil fuels create lot of pollution. It will emit lot of pollution, and then we have the Kodangam in our state. It might be possible to get accident, the nuclear discharge. To solve all those issues, only solar cell is the only one thing, because in solar cell is the renewable energy, and then it will not give any pollutions. And then compared to other technology, why only solar cell? As we know, we are nowadays mainly depending on the two different type of energy sources. One is the renewable energy sources, another is the non-renewable energy sources. Nowadays, we are mainly using the non-renewable energy sources. For example, coal. We know the petroleum, coal, and then uranium, as well as the natural gas. The availability of this non-renewable energy sources, it's very less. And then I mentioned how much is available. It is calculated in 2015, but still, in day by day, we are keep on using this non-renewable energy sources. Maybe it's soon going to get dry. Once the energy sources will be dry, then our future generation where will go. So due to that reason, some foreign countries already started using some renewable energy sources. For what are the renewable energy sources? For example, wind energy, biomass energy, hydro energy, as well as geothermal wave. So all these energies are there, but still if you using the wind energy, for example, we need to take wind from energy. After taking energy, we need to transport one place to another place, and then we can't have the transport. We need a lot of wires and a lot of things. So due to that reason, wind energy also a little bit costly, and then biomass, hydro, geothermal, this kind of technologies are very less. When you look at the solar energy, it's available 23,000 terawatt. So if you use the solar energy just 1 to 2%, we can solve all our energy crisis. According to World Energy Consumption in 2015, they calculated per day we need around 18.5 terawatt. Yes. So if you use continually this technique, automatically we will get short out in soon. So due to that reason, people are looking for solar energy. Already we know the petroleum, diesel, gas, already the rate also keep on increasing due to that reason, the availability of the thing also. And then next, what types of solar cell? Depending upon the produce the light energy to electricity, people are using many different type of materials. Depends upon that materials, the solar cell mainly classified into two types. One is the organic solar cell, another one is the inorganic solar cell. Organic solar cell further classified into many types. One is the dye-sensitive solar cell, organic solar cell, and then perovskite solar. Similarly, inorganic solar cell also further classified into silicon-based solar cell and then non-silicon based solar cell. As we know, all of us now we are using the silicon based solar cell. Whatever the solar panel we are currently using, that is mainly based on the silicon based solar cell. Some of the non-silicon based solar cells also available, but it's a little bit costly compared to silicon solar cell, as well as the stability is very poor. Due to that reason, we are mainly using silicon based solar cell. And then another is organic solar cell. Solar cell also people are using DSC, organic solar cell. Perovskite solar cell recently started, but it's due to the poor stability of this solar cell technology, still we are using for the silicon solar cell. So they are classified into mainly three different generations: first generation, second generation, as well as the third generation. Initially, people start using the crystalline solar cell. It's achieved 25.6% PCU. Further, they developed a multi-crystalline solar cell as well. After that, second generation solar cell mainly amorphous polycrystalline. These are the polycrystalline solar cell. Other some non-silicon based solar cell also comes under second generation solar cell. For example, copper, indium diselenide, cadmium, telluride solar cell. But now we are mainly using a third generation solar cell. The third generation solar cell, dye-sensitized solar cell, it's achieved PC around 17%. And organic solar cell as well as perovskite solar cell in tandem solar cell. Here I mainly discuss about the organic solar cell because here most of the organic materials are used to produce the electricity. So in this conference also mainly focusing on the polymers. So what type of polymers has been used for the organic solar cell, and then how to devise fabrication for the organic solar cell, and then how to tune the materials. And then perovskite solar cell, one of the growing field in the solar cell technology. So due to the higher efficiency achieved in very short time. With the perovskite solar cell started in 2009, just 3.9%. Within 12 years, it's attached at 25.2%. You just see it's very close to silicon-based solar cell. Silicon-based solar cell also just 20.56%. It started long time back. So before going to device fabrication, means what is mean by semiconductors, insulator, and then conductors. We are mainly using for the solar cell techniques for the semiconductors. So what is mean by insulator? When the valence band, conduction band, the band gap is the maximum. So that is called as an insulator. There is no electron flow between these two. Then the valence band and conduction band are the minimum. So that is called as the semiconductors. Nowadays we are mainly used for solar cell system is the semiconductors. Under the next one is the conductor. Conductor, the valence band and the conduction band, there is no band gap. This is called as the condenser. As I already told, silicon-based solar cell one is the widely used material for the solar cell application. The silicon having outermost electron, 4 electrons are there. So while using solar cell application with silicon, we are not using for pure state. So when you pure state, then silicon is the highly inert, it will not give any current. Due to that reason, the silicon has been doped with two different types of materials. One is the pentavalent impurity, one is the trivalent impurities. If you dope the pentavalent impurity, for example, lead arsenic tin, if you go, this is the pentavalent, that lead having outside only 4, this 4, this is a pentavalent. 4 and 4, it will get bond. Extra electron will be there, na? That is the donor impurity. It having the electron free. The moving electron will be there. So that is the electron rich material, is the N-type material. If you do only trivalent impurities, for example, gallium boron, this is the only three valent, but silicon having outside is the 4 electrons. So 3 only it will get bonding. 1 electron will be free. That is called the hole. That is called as the P-type electrons. So what is in the solar cell? And then especially for organic solar cell. Organic solar cell mainly made up of the many types. One is the single layer, high layer, and then bulk heterojunction, inverted structure, this kind of thing. Here I given the example for bulk heterojunction device structure. In bulk junction device structure is nothing but the active layer consists between donor and acceptor. So here the active layer mainly consists of two different type of polymers. One is the donor and one is the acceptor. For example, here the people are widely using P3HT is the donor and then PCBM is the acceptor. So here what type of polymer has been used, why the polymers are used for the organic solar cell application, how to coat this device. For example, we will take the glass place, ITO coated glass place, over we need to coat the P.PSS by spin coating method, and then active layer consists of two different material. One is the donor, another is the acceptor. What is the role of donor acceptor? Here the polymers as well as the PCBMs are there. So when light strike on the active layer should absorb the photons. After absorbing this photon is created as the excitons. After the excitons will be generated due to the opposite negative, positive or negative electrodes are try to extract the holes from electron from the active layer. So here mainly people are using material for P3ST. This is one of the well-known polymer for organic solar cell application. PCBM as I used. Similarly, P.PSS is also used for organic solar cell for the lithium fluoride as well as the metal. What is the advantage of this kind of device structure? This device structure can be made very easily because that ITO P.PSS active layer, lithium, this all the active layers and P.PSS coated by simply spin coating techniques, and then lithium fluoride metal electrode coated by thermal evaporation, and then this can make very small place as well as the easy device fabrication technique, and then this is a very low cost weight and then lighter weight. We can able to the flexible substrate also. So how the solar cells are working? As I saw the device structure. Device structure means I will tell you what is the device structure, and then what this device structure containing glass plate, ITO, P.PSS, and then active layer. Here I also used the same glass and then coated ITO places as well as the P.PSS. LUMO, this is called the active layer, and then lithium fluoride aluminum, right? The same device layer I used in this way to explain how the organic solar cells are working. So here I used the HOMO and LUMO level and the energy gap of the corresponding material. What is the donor HOMO LUMO level and then acceptor HOMO LUMO level? So I mentioned in here the HOMO LUMO energy level, band gap as well as. So we know the sunlight having the bundles of photons. So what will happen when the sunlight strikes on the active layer? For our device, the device try to absorb the photons. Okay, once the photons get absorbed, it's created as the excitons. Excitons is nothing but hole and electron pair. You just took the donor will absorb the photons. It's created as the excitons. Excitons is nothing but hole and electron pair. After the hole and electron pair, it will try to diffuse in the donor acceptor introduce. As we know, donor is the electron rich material. We have the electron acceptor is the electron deficient material due to the opposite charge. This is the positive, this is negative. What will happen? Try to separate the electrons. The negative part try to extract the electron, and then positive part try to extract the hole. So here the electron the acceptor try to take hole from the excitons, and then donor try to extract electron hole from donor. So and then the electron it will move to the acceptor LUMO level. Similarly, hole it will move to the donor HOMO level. Further here to here, the acceptor LUMO level to electrons it will move to lithium fluoride jump, and then it will go to aluminum. Similarly, here also hole it will jump donor HOMO level to P.PSS HOMO level. Further it will go to ITO electrodes. So here, initially I mentioned the power consumption efficiency. I mentioned some number 25.2 and then 23.5% efficiency. This kind of efficiency already I mentioned. What is that number? So if they're using the number formula, power consumption efficiency main directly proportional to open circuit voltage as well as the fill factor and then short circuit current. The JSC is called short circuit current, FF called the fill factor, VOC is called as the open circuit voltage. So if I mention 25.2, in case our device around 100 photons are striking to our device can able to extract only one photon, only one electron. That is called 1% PCC. If our device can able to extract 25 electron, that is called 25% efficiency. Now you may be clear about the power consumption efficiency. So after making this device, okay, then you will get this kind of IV graph. So to calculate the power consumption efficiency after making device, we need to connect anode cathode. Then we will get this kind of graph. Okay. So from this graph, so see you can look at the open circuit voltage and then short circuit current as well as the fill factor. It's three are directly proportional to the power consumption efficiency. If you can able to increase just any one factor, automatically the power consumption efficiency also can be increased. So here the open circuit voltage, how we can able to increase the open circuit voltage. How we can able to increase the fill factor? How we can able to increase the short circuit current? So the open circuit voltage mainly depends upon the donor acceptor homo energy levels. So the homo energy level of donor is very close to feeder PSS. So what it will happen? The whole donor to feeder PSS easily jump. Similarly, the acceptor LUMO level to lithium chloride LUMO level is very close. Automatically, the electron also easily jump here to here. In case this the band gap is the maximum, the energy gap is the maximum. So what it will happen? So the energy gap is the maximum. So it will the hole in the electron pair try to recombine. Okay? So if the recombination will be more, automatically we will get the energy loss. So due to that reason, we need to maintain the energy level is the optimum. So for that reason, we need to select the material. And then the second point. So we know that all the material having different kind of absorption properties. So some material can able to absorb good number of photons, some material can able to absorb less number of photons. So if the photons can be absorbed very nicely, so in case 100 photons are striking to our device can able to absorb 100 photons, then we can able to get good number of PCE. In case our material can't able to absorb all the photons, then we'll get loss itself then. So if our device can able to absorb more photons, then we'll get the good number short circuit current, that is the JS. So how we can able to increase the absorption? For example, we know the what is the polymer. We have last 2 days most of the professors discussing what is the polymer. The polymer having the most long chain means bulky materials, right? So this is the most number of repeating units. So if more number of repeating units are there, automatically more pi conjugation will be there. If more pi conjugation will be there, the material can able to absorb more number of photons. Like, so how we can able to check the absorption properties? So like we know the UV visible absorption spectrum. After synthesizing that material, we need to check the UV visible absorption. Then you will get good absorption property. Then this material having the good absorption property, right? So this may be this. Here we are getting clear. Then automatically we are in good. And then fill factor. So you just look at how many different type of layers are there. In each and every layer we are making different time, right? So if you are making different time, the smoothness between these layers, right? So the PSS active layer, between these 2 layers as well as the lithium fluoride active layer, the surface between these layers too, they are good, then we will get good fill factors, right? So different type of materials can be used. Already I mentioned PSS, PCBM are already used. Apart from that, what type of material can be used for organic solar cell applications? For example, donor we can use polymer as well as C6 derivative. Already I mentioned P3ST, PCBM, and then C60. These derivatives can be used as acceptor. Polymer P3ST, some other polymers also have been used. For example, MDMOPPV, some PC carbazole based polymers. This is a donor acceptor polymers. In small molecules and then C60 derivatives as well also we can use for active layer for organic solar cell application. And then small molecule we can use SMPV1 as well as some small molecules C60 also we can use for the active layers. So apart from why we need to use only conjugated materials, already I explained what we use of conjugated materials. We know all the materials having different color depends upon that absorption property. The absorption property mainly depends upon the color. Then the material having some high red, then the material can absorb more number of absorption properties. So there, and then the band gap also can be tuned. Already mentioned what the use of band gap. So you can look at this working diagram. You can see the energy gap is very important. If the maximum, the band gap is the maximum, then we will not get good PCE. So we should maintain this energy level. So we need to tune. So the people are using different type of material. For example, polyisobutadiene, polyacetylene, P3STSLS, and then polyphenylene, and then polydimethylamine. So how to reduce the band gap? So you can look at this material. This material having the 3 band gap is the very maximum, and then 1 band gap is the very small. For optimum band gap for organic solar cell around 1.5 to 1.6. If it is the maximum band gap, we can't reduce for the organic solar cell application because the HOMO level it will not match. So to reduce the band gap, people are designing 2 different type of material. One is the donor acceptor type material. So the donor type means very electron rich material. Acceptor means electron deficient material. So if you combine these 2 materials, this material how we can able to combine? The organic chemistry can combine via synthesis, these two materials. For example, triphenylamine, oligothiopene, and then phenothiazine, pyrrole, carbazole, thioprene. This kind of all the materials are electron rich. This will act as the donor. And then electron deficient, people are widely using benzodiazole, diketone, pyrrole. These are widely used accepted material for organic solar cell. When we'll combine these two materials, this is electron rich and then electron deficient. So what it will happen? So it will happen the electron transfer donor to acceptor. Donor try to pull the electron from the donor, and then the donor will give the electron to acceptor. So due to that reason, the charge transfer will happen. The donor to acceptor, the charge transfer will happen. So here all the materials will try to move one material to another material. Due to that reason, so the intramolecular charge transfer will happen. So the donor will accept the photons, automatically it will transfer to here. Then the flow of the electron will be more. So we'll get good number of absorptions. So this is some other type of polymers which are used for the organic solar cell application. So this conference mainly based on the polymer based. So I want to give some of the example for polymers, which are the polymers mainly used for the organic solar cell applications. Mainly people are using donor acceptor type polymers because the donor acceptor polymers having the good maximum absorption. You know the polymers having very broad absorption range. Due to the broad absorption, the polymer can absorb more number of photons. So DA type polymers are widely used for the organic solar cell applications. Here the 4.2 is the performance efficiency, and then the band gap is the 1.9. Similarly, 3.6 is the band gap. This is the corresponding publications. And then, so up to now, I discussed the organic solar cell applications because this solar conference, as I mentioned already, this polymer based. So organic solar cell mainly consists of polymer. So I gave just example for organic solar cell. Now I will talk about the perovskite solar cell. Why the perovskite solar cell is very important than organic solar cell? So what do you mean by perovskite? Perovskite is nothing but which material having the calcium titanium oxide structure, that is called as the perovskite. This is the structure is the AbX3 structure. Here A, B are the two different types cation, X is anion. For example, methyl ammonium, methyl lead, MAPBI3. This is called one type of perovskite. So mainly people are using methyl ammonium or organic inorganic halide. Here, so I just show that how to synthesize the organic inorganic halide mixture. Here the methyl ammonium as well as lead iodide. Just mixing this, you get the methyl ammonium lead iodide. Here the methyl ammonium is the organic part, lead iodide is the inorganic part. So what is the advantage of this perovskite solar cell? So why the perovskite solar cell is much attention compared to other solar cell technology? You just look when the other solar cell technology has been started. For example, organic solar cell. For example, organic solar cell started long time back, but still the efficiency they touched to only 12 to 16%, or sometimes 18%. So here the organic solar cell, what the red color various type, they started long time back, but still they are achieving PCE only for 16 to 17. That's the maximum PCE. But perovskite solar cell they started in 2009, just 12 years before only they started. Starting itself they get around 3.9%. In 2020, they achieved 25.2% efficiency. It's very close to silicon-based solar cell. So due to that reason, the efficiency is very higher, and then the material synthesis is very easy. So due to that reason, the perovskite solar cell is much intensive in solar cell technology. So in perovskite solar cell, how the organic materials are influenced. For example, perovskite materials are made to one is organic, inorganic halide. For example, organic material, what type of organic material? Already I mentioned methyl ammonium is the organic. Apart from so many organic material, cation has been used. For example, N-butyl ammonium, isobutyl ammonium, some exile, 6 carbon chain as well as fluorine substituted carbon chain, or the acid substituted, amine substituted, different type of material has been used. Depends upon this material, the absorption properties and then band cap, HOMO-LUMO energy level can be tuned for the perovskite materials. If you want to increase the HOMO level, they are substituting this kind of material. If you want to increase the solubility of that material, they are using the long chain materials. So you can look at what different type of materials are perovskite material for MAPBI3, MAPBI2, and then one bromine is being changed. Just only one bromine they change, and then the LUMO level suddenly up. If you change this kind of just small modification, we can easily tune the LUMO energy perovskite. Yes. And then another thing, the perovskite material can absorb up to 800. We know the UV absorption spectroscopy start from 200 to 1000, but maximum we are keeping the 800. So the perovskite material can start absorbing 200 itself, and then it reach up to 800. It is having the good absorption properties, and then it having the optimal band gap 1.55, and then the solubility is very easy, then it's highly crystalline nature. So what different type of device structures are available for perovskite solar cell? Perovskite solar cell mainly connected to different device structures, and then different type of device material have been used. For example, TiO2 is the electron transporting material, and then perovskite, and then hole transporting material. Further, similarly here also STM is downside, perovskite, PCBM, and then silver and gold. So I mentioned a lot of time device. What is the device? So this is a device made by myself in our lab. You can look the device. When you look at this, is a different type of layer. The whole the device are made just in small glass. This is the glass FTO coated glass plate, and then over we coated up to the TiO2 perovskite STM coated layer. These are the 1, 2, 3, 4 layers coated material. This is the gold coated. You can see the top side. The gold material has been coated on the top side of device. So this is a different type of device which was used for the perovskite solar cells. How this device are working? How the device are working? So that similarly, I already explained how organic solar cell working. The perovskite solar cell also similarly working, but here the perovskite is playing major role. The perovskite itself will absorb all the photons, and then it will itself be the create as the exciton, and then it try to separate the hole and electron pair. Here the perovskite is the, we can say, the hero of this device. That's what is perovskite solar cell. And then to support perovskite, people are using spirometer, the hole transporting material, and then TiO2 is the electron transporting level. Here also same concept. The perovskite having the HOMO and LUMO level at 5.42 as well as the 3.9 is the LUMO ionized level of perovskite. If the HOMO level of perovskite to hole transporting layer is very close, the hole it can easily transfer to here. Similarly, the perovskite HOMO level to TiO2 HOMO level is very close, then the electron can easily transfer. If the energy levels, the HOMO and LUMO levels are very close to each other, what it will happen? The hole and the electron will be recombination. Again, it will form as the recombination. So here also the losses will be more. And then here, what is being made the power condition efficiency already explained. It's mainly depends upon the open circuit voltage, fill factor, GSA. The concept will be same for organic solar cell as well as the perovskite solar cell. So here, how the open circuit mainly depends upon. Here also is same thing. The energy gap between HOMO of perovskite, HOMO of donor. If the energy gap is the minimum, the hole can easily jump. We will get higher VOC. Similarly, the LUMO to TiO2 energy gap is the minimum, then we will get a lot of open circuit voltage. Automatically, the power condition efficiency will be increased. Fill factor mainly depends upon the layer interface. The interface is good, then automatically you get good fill factor. And then short circuit current. JSC is the short circuit current. The perovskite material will absorb good number of photons, so we'll get automatically higher short circuit current. So that is the reason we are getting good PCE. So how this device are made? So already I showed the device structure: glass, FTO, TiO2, perovskite, STM, and then gold and silver. So first we take the FTO plate and then fluorine doped tin oxide substrate. That is a glass over FTO coated. We take directly this plate is commercially available. Then pin coat on TiO2. TiO2 is the titanium isopropoxide dissolved in ethanol solvent, just coated over the FTO surface by the spin coating method. After that, we just go for the perovskite solution. We know what is the perovskite solution, that is methyl ammonium iodide and lead. No need to just mixing these two materials, you get the perovskite. Some stoichiometry method, and then we'll get the perovskite coated over the TiO2 just for spin coating method. This one also spin coating method. And then the spirometer is the widely used gold transporting material for perovskite solar cell. And then this one also coated over the perovskite by spin coating method. And then electro deposition means thermal deposition of gold as well as silver. So this is a complete device structure, right? So this is the device structure is same images. So how I mentioned that spin coating method. Spin coating method is nothing but we just dissolve some sampling suitable solvent, and then take some in the pillar, and then just a drop over the substrate, just rotate it. Then the sample gets stick on the place, substrate that people are using two different types of useful for the small scale. When you go for the labs are used, this is content used for long, and then the loss of only all the material do not stick over the substrate. Loss of material will be losses. So this is low yield material. So the only this is used for the lab. So when you go for the industrial level, they're using the doxyblade, roll to roll, as well as the spray coating technique to coat that kind of device. So already I explained two different types of materials are playing major role in perovskite solar cell. Apart from perovskite, actually perovskite is the major. Then after perovskite absorbing photon, two materials would there to take electron as well as the photon from perovskite material. One is the electron transporting material, and is the photon transporting material. So what? So we know what is the main electron transporting material. The electron means it should match in the energy level, and then it should efficiently extract electron from perovskite, and then it will compatible with the perovskite as well as, and then high electron mobility, and then the band gap should be matched. So what type of material has been used for the electron transporting material? People are widely using inorganic material is the electron transporting material, TiO2, zinc oxide, etc. But still, some of the organic materials also can be used for the electron transporting material, for example, PCBM as well as Berlin derivatives. So we know what is the PCBM. This is C60 bulk crystal fluorine is called as the C60, and then some modified fluorine also used for the electron transporting material. Here, some of the polymers also can be used as the electron transporting. This is a Berlin diamide substituted by thiophene. This material also used as the transporting materials. Another technique is the old transporting materials. What type of old transporting material has been used for perovskite solar cell? Already I showed the spirometer, one of the widely used old transporting material, and then I showed the structures also while making. So the what type of character should be there? It should match with the HOMO level, with higher conductivity, good solubility, and then good thermal and photoconductivity, good film forming ability. This material should be low cost and easily processable, and it should be selectively extract. It should not extract electron from the perovskite. It should selectively extract gold only from the perovskite. This is the structure of spirometer. This is a widely used material because this is good solubility, well matched energy level, higher PSC performance. Why pick material? But these materials also having some disadvantages. These are organic materials. So this material is highly cost, maybe 1 gram around 38,000. And then low conductivity and mobility in crystalline state. In crystalline state, this material having very low conductivity stability and less stable. This material easily oxidates with air. We know the stability of perovskite is very important because after making this device, we are keeping the outside atmosphere to absorb light. So this material is very poor, then automatically our device will get lost. So due to that, the spirometer should be more stable, but this material is not acting as the most stable. So due to that main reason, people are searching some alternative for this spirometer. Another thing, this spirometer in crystal state, low conductivity and mobility, and then people are adding some lithium salt and TBP as a dopant into perovskite to enhance the conductivity and mobility. After adding this to this conductivity is significantly enhanced, but another disadvantage after adding this to the stability of spirometer still work because the highly hydroscopic nature absorb water from the moisture. So perovskite just touching the water, the device will be completely disadvantaged. So due to the reason, the finding alternate for the spirometer is very important. What type of Start. Sorry, sir. Some internet issue. Sorry. So already explained the spirometer is the whole transporting material, and then what are the properties are required for the spirometer materials. So apart from what type of materials, spirometer, PTA, and then P3ST are also used as the whole transporting materials. After that, apart from what type of material has been whole transporting materials, some of the DA type whole transporting materials are used, and then they achieve 16.8%. So this is the power quality efficiency we can see in the only perovskite solar cell. If you make the organic solar cell, you can get only 4 to 5%. In case of dye-sensitive solar cell, also will get very poor efficiency. But when you do for the perovskite solar cell, we'll get good number of PCE. Apart from the spirometer, a lot of people are trying to report most of the other whole transporting materials. So these are the whole transporting materials used for the perovskite solar cell. These are the efficiency as well as the PCE. So how I work on this type of device. So as we know, the spirometer is less costly. So due to this, I designed myself as a material. So this is the design 2 material. Here the thiazole is the center attached to the triphenyl moiety, and then dicyanovanillin touch the triphenyl. I mean, how this material has been synthesized. So I took amine methoxy substituted the benzene just for cyclic get the reaction condensation. So one time planning used, and then I got the triphenyl amine methoxy substituted triphenyl amine. After that, I formulated using POCL This is a Wills-Meyer formulation reaction. This is everyone knows. After that, get the aldehyde group. We know the Navanagh condensation aldehyde, and then this CH2 react, and then we'll get the olefin double bond. So I got this product as well as the cyclization reaction of dithioxanide. I will get this reaction. You can do this material is very easy to synthesize. I did not use any phosphoric acid, and then this I did not use any column because this is this simple Navanagh condensation. The byproduct is very good, and then I got around more than 90% yield. So other advantages, this material is very planar as well as the low cost. Cyanovinyl P2 is an important acceptor. I mean, easy to synthesize this material. So what is the advantage of this material? So I do comparison between the Spiro and then our synthesized material. Spiro having very lower absorption. So, but our material having a good absorption. So we know that our material having good absorption, then compared to Spiro, maybe our material can also absorb more number of photons. Similarly, this is the energy level diagram. So I compared with Spiro, and then our material is very close to spirometer homo level. So we can able to easily electricity, a hole can jump space. So what is the energy level? I'm talking initially on this, how to calculate the energy level for organic materials. Organic materials we need to use a cyclic voltammetry. From cyclic voltammetry, we can able to calculate homo and LUMO energy level. So how we can able to calculate from cyclic voltammetry? As we know, cyclic voltammetry won't take the oxidation, unless it will take as a reduction. If we get oxidation from the onset oxidation potential, we can using this formula, we can able to calculate the homo energy level. For example, I took spirometer for the standard. When you go for our new material, we need to always go for the standard material. Standard material how much giving, then our material how much is giving. So I've done all 3 materials for the cyclic voltammetry. You can look at the spirometer that oxides after 0.8, but our material starts some of the material 0.8 itself, and then but the TT is at a little bit higher. If you go this side, we will get the higher lower homo level. So the perovskite is the 5.4, TT is the 5.24. It's very close. But spirometer is the 5.17. So due to that reason, compared to Spiro, our materials are really good. So and then I done the device fabrication using the same. Instead of spirometer, I incorporate our 2 material as the whole transporting material, and then I got impressive efficiency. Spirometer I got only 11.62, but our material around 11.37 and then 10.11. This is why, because the spirometer is higher. This is already well-known material. Many number of people have been done for device fabrication for this material. Due to that, this is showing higher PCE. But our materials are somewhat late. But this new material, low-cost material, still gets completed with the spirometer. So this is a good material. And then I mentioned the stability. As we know, the spirometer having a highly hydroscopic nature, we see get oxidation. Due to that, spirometer is very low stable, but our TGs are having the higher stability. And then I mentioned the costly. Spirometer is 170 to 470 1 gram, but in our material we can see that 8.64 and then 24 94. This cost also very less. And then this research work has been published in AC Software Energy Materials in 2019. So after that, as I discussed, spirometer requires some of the dopant. One is the TBP, another is the lithium salt. So and then I got some STM idea, but after that, why we can synthesize some other dopant instead of synthesizing new STM. So I thinking I just took survey of what type of dopant has been used for the whole transport material to boost electricity and the whole mobility of spirometer. So I checked this is a standard lithium and TBP are people using, and then FK20 as a core dopant is used for this boosting this material. Apart from that, benzyl peroxide, zinc, and then F4, and then BCB of copper, BCP. I took all the material survey, and then I decide one material. So you can look at that materials. All the materials having good PCE, but compared zinc is very higher PCE, but BCP is somewhat 43.6. Recently, this material also little bit including other technology. So taking that idea, I designed one material, just one step reaction of amine aldehyde diol. Just cyclization of this reaction, I got this PFPPY dopant. You can look at this dopant. This dopant having the pyridine. You just took TBP having the pyridine unit. Due to that reason, it is widely used. And then have around 10 fluorine units. We know what is the advantage of fluorine unit. If we can able to substitute more number of fluorine units can able to enhance the electronegativity of the particular material. It having the highest thermal stability as well as the moisture stability. To that reason, a lot of people want to incorporate fluorine itself with the whole transporting material. For example, just I will show you. See, this is some whole transporting material itself. They want to incorporate the fluorine unit. If you incorporate the fluorine unit, you just compare non-fluorine and fluorine unit. The non-fluorine unit is just 11.3%. After substitution of fluorine unit, it enhanced to 14.50. See, and then this spirocore, their substitute is just only 2 fluorine, 3.9 to 18.13. How much difference will be there? So due to that reason, most of the people want to incorporate fluorine into their materials. So I incorporate fluorine as well as the pyridine. So I designed this dopant into a new dopant for spirometer. This is absorption factor of PPF, PFP. This is a cyclic photometry. From cyclic photometry, I calculate the HOMO level of the spirometer, the PFPPY. This is around 5.5. So I have done the theoretical calculation also. What is the HOMO luminosity level? The synthesized material. It's almost very close to each other, the theoretical as well as the experimental value. After synthesizing that material, I just add into spiro, because we are using this as the dopant for spiro. So pure spiro having no absorption peak after 400. Already, so from my previous work, after 400, the spirometer don't have any absorption spectra. But when I add the PFPPO into spirometer, here the black line indicates the 0%, that is a pure spirometer. After adding 5% of my dopant, it get oxidized. The spirometer get oxidized. Due to that reason, I started getting one new absorption peak range at 525. And then the second absorption peak also started 600 to 800 range. Further increasing the concentration of PFPPY, the absorption intensity of the first peak is very intensely increased. And the second absorption peak also start increasing, right? Due to so what information from we will get? The dopant our spirometer is very strongly interact. For example, the pyridine, and then the spirometer, it's strongly interact with the spirometer. It get oxidized very hugely. Due to the reason we get this kind of curve. So the interaction is good. So after interaction this, and then this, we know the organic radical cation is confirmed by the EPR, electron spin resonance spectroscopy. I have done the electron spin resonance-spectroscopy of the spiro, lithium salt as well as the spiron. This our sample, and then we get this curve. After that, I want to check the conductivity as well as the mobility. When I look at the pristine spiro, it's very low conductivity. After adding the standard dopant, TBP FK209, the dopant was increased 1 order magnitude, 10.5, 10.6 to 10.5. After adding my dopant, just spiro lithium as well as the my dopant, it's increased 2 order magnitude, 10 point minus 4%. Similarly, the conductivity also increased. Similarly, the mobility also jumped to 10.6 to 10 minus 4 with my dopants. After that, I want to confirm the how the compatibility with the spirometry and my dopant. When you use the TBP FK20 dopant, I find lot of holes and then pinholes. From the pinholes, the moisture can penetrate from top side to perovskite. It can easily degrade. But in when I look my device, you can look, there is no pinhole. It's very smooth and then good surface. So due to that reason, our material is really good compared to the standard. So after that, I made the device with that materials. You can look at this is the IV curve. In this IV curve, the standard is the red colors are standard. This is the PPY is the blue colors. This is the forward and reverse. Two different curve has been I showed. You just see the standard is showing around 19.6% for reverse, but in our material is showing 21.38%. This is one of the highest PCE with new dopant for perovskite solar cell. We have done very good achievement, and then we have checked the stability. This is the standard. The red color one is the standard. The blue one is the our material stability. So after making material, we store in the dark condition, and then we check keep on interval. When you found the standard device, it's completely start degrading very quickly, and then 600 hours, it's get around half device is gone. But in our case, in 600 hours, only 95% still is sustained. So this work has been published in Nano Energy. It's very good journal on impact 17, very close to 17. So what is the futures of organic semiconductors? For example, already I mentioned, nowadays we are mainly depending on the petrol, gas, and then due to that reason, it's daily the rate of keep on increasing. So due to that reason, we want to move to the renewable energy source. Already some foreign country, already they started using the energy sources. For example, China, I am living, but in China, they're always using the electrical cooker, electric scooters, electrical train, electric bus, electric car. So they are saving their place, and then they're not using much in petrol gas, but we are mainly depending on the petrol gas. So we need to switch petrol gas to our renewable energy source. If you use this energy, this is unlimited. It's available such a long time. So for example, toys, watch, calculator, also we can use satellites, nano satellites. Already people are using only for solar cells, and then satellite, nano solar cell, LED system. Also we are already using. These are some other medical field also we can use, and then submarine also for some tripping we can able to use. So thank you for attending this one. So if you have any queries, please ask. Thank you all.
Thank you, Professor.
Thank you, sir. Sorry, sir, in between some internet issue I got. Sorry,
Okay,
sir.
bro. One second, Professor.
Yes, sir.
I thank to our chief guest, Dr. G. Satyan. He clearly explained about the solar energy, need for sustainable energy, first generation cells, second generation cells, and he clearly detailed about the organic solar cell works, materials of BHJS solar cells, fused pi conjugated DA polymers, and structure and the working principle of PSC device, organic electron transporting material, photophysical and electrochemical properties of photovoltaic performance of PSC, photophysical conductivity and hole mobility features of organic semiconductor. Thank you, sir. Thank you for your adorable presentation, sir.
Thank you. Thank you.
Thank you, Professor.
Thank you, sir. Sir, any queries I can answer, sir. Any queries, any doubt?
Professor, no queries.
Okay, sir.
Okay, thank you, bro.
Thank you, sir.
Thank you. Okay, thank you very much.
Thank you, sir. Thank you.
Screen share.
Now I invite Mr. N. Chandrasekharan, Assistant Professor, Department of Chemistry, Sri Vidya Mandir Arts and Science College, to welcome and introduce our chief guest.
Good afternoon to everyone. I extend a warm welcome to all on behalf of our department. I feel very happy and proud to introduce our today's resource person, who is our college alumni, Dr. Raja Nehru, Assistant Research Fellow, Sustainable Environmental Research Center, National Kaohsiung University of Science and Technology, Kaohsiung City, Taiwan. He obtained his undergraduation from Sri Vidya Mandir Arts and Science College, Uttangarai, in the year 2014, and his post-graduation from Bharatiyar University. He obtained his PhD degree from National Taipei University, Taipei, Taiwan. He did his postdoctoral fellowship from National Taipei University of Technology, Taipei, Taiwan. He has won number of honors and awards like TTS Young Research Award 2019, Taipei, Taiwan, National Taipei University of Technology Sunshine Scholarship Award 2018, 2019, and 2020. He has published 17 research papers in SEA journals and presented his research papers in various conferences and workshops. He is a reviewer for SEA journals in the field of nanotechnology, material research, express microchemical journal, and a new journal of chemistry. His research areas are nanoscience and technology, material chemistry, electrochemistry, electrocatalysis, photocatalysis, hydrogen production, electrochemical pollutant monitoring, food sensing analysis, sensors. With due respect, I welcome our resource person, Dr. Raja, to deliver his special lecture. Thank you, Raja. I welcome you to give your lecture. Thank you.
Thank you, sir. Thank you, sir. Thank you for wonderful introduction about me and our colleges and my research. So thank you so much for this opportunity giving me, and I wonderful thank to our SVM college and faculty members of Department of Chemistry. So, and special thanks to Professor Govindraj to inviting this conference on this occasion. So now I'm going to share my PPT. Hello, can I share my PPT, sir?
Share பண்ணுங்க ராஜா.
Okay. Hi. So can I start now?
Yes.
Okay.
Please continue.
Okay, sir. Today, I'm going to deliver my speech in the title of Advanced Nanomaterials Towards Sustainable and Environmental Application Aspects. So, first of all, I introduce myself. Raja Nehru. I did my bachelor in SVM College in the Department of Chemistry. I happy to share this here, and I finished my master degree in Bharatiya University, Coimbatore. After that, I moved to Taipei to I did my PhD. Then I moved to forward for postdoctoral research position in the same campus, National Taipei University of Science and Technology. Then I moved forward for the assistant research fellow in the Department of Sustainable Environmental Research Center in Kaohsiung, National Kaohsiung University of Science and Technology in Kaohsiung, Taiwan. So now I'm going to start the speech. In this session, I'm going to discuss about the nanomaterials toward the environmental aspects for the sustainable materials towards the environmental aspects of pollutants. So first, we go with basics to understand clear understanding. So I start with nanoscale materials. What is the nanoscale materials? The nanoscale materials, the future size of the materials less than 100 nanometer, which is called the nanoscale materials. So how to utilize these materials to these different kind of applications? So first of all, we can clear with what is the nanoscale materials, how it the structural features, and how the structural features are effectively include or apply the different applications. So for can see the first image, the gold nanoparticles, which were first identified the European synchrotron radiation facilities program. They achieved the through X-ray diffraction microscopy. You can see that the nanoscale materials of gold nanoparticles, uh, the scale of the materials up to 100 nanometers, and also we can see the silver nanoparticles. Can see the silver nanoparticles, which were helpful for the optical sensing, optical applications. And further we move forward, we can see the quantum controlled positioning ion atoms, and three-dimensional nanostructure grown by the controlled nucleations of silicon carbides, nanowires in the catalysis applications. So before, what is the nanomaterials and what is the nanotechnology? So how it, it will be vary the nanostructures and nanofeatures when reducing the nano-sized materials and when increasing the size of particle size of the materials. So first we can see in the, for example, we can see in few examples here, the cluster materials, nanocrystals, quantum dots. For example, the quantum, we can take quantum dots. When we reduce the the size of the materials below 10 nanometers, that time we can we can visible the particle size, which will be luminescence property, which will give us the luminescence properties, so which can helpful to different application, especially in the chemiluminescence applications. For example, the insulating behavior materials, semiconductors, metal, magnetic materials. We can consider other material also in the radius of 1 to 100 nanometers, which call the which use the nanostructure features. For example, ceramic oxide, bulky balls. and then we can move the carbon materials and nano wires, for example nano tubes, which were helpful to use the composite materials. When we use the composite materials, it will more effective for the application aspects. So what is the beauty of nano? So we need to know the beauty of nano. Using new tools, scientific tool, we have found that nano-sized particles, the substance, the different properties than larger particles. So when we using them, one substance in different the nano-sized materials gives different properties. When that will be when you decrease the particle size. For example, we can see in nano materials. Here we use different approaches. For example, top-down approach, bottom-up approach. For example, here we can see that the bulk materials of for bulk materials converted into powder. So to clear understanding, we can take one example for black peppers. We can take black pepper. That when we eat the black pepper directly, the effect of the spices not that much effective, right? So when we grind the pepper powder, that time it will reduce the particle size, which means the size of the nano pepper particles reduce the size to powder formation. That time we feel a little bit spicy. Then we make more we reduce the size of the particles little more, then we feel the spices of the pepper, we feel more effective. We can understand for I give the understand for this clear understanding for students. So at the same time, we can for take example for bottom up approach. When the atoms combine to one more atom, that time it will form the cluster formation. Then it will comes to the nanoparticles formation. We in nanotechnology we analyze we approach two different types. So one top down approach, another one is bottom approach. So if at the same time, when we study the nanoscale materials, we can learn the nature of the matter. For example, we can see the lotus leaf. We can take the lotus leaf. It is inspiration of nanotechnology. So how the when the particles, for example, for water, when enter the water molecules into that leaf, that will not absorb the water molecules, which means it gives hydrophobic nature, that cannot able to absorb the particles, uh, which means the surface of the nano-sized particles observed in that leaves. So for at the same time, these properties can develop new products and new technologies, new application point of view. One more example we can take nanoscale. If when we analyze the surface of the shark fish, that time we can see here we can observe the nanoscale pattern. We can observe the nanoscale patterns, which will helpful to prevent the bacterial infection through in the water medium to the shark fish. So this is the beauty of nanotechnology, and especially about the nanotechnology. It will more helpful to understanding the upcoming students. So why we need to use nanomaterials or nanoparticles to the application point of view? So as I told earlier, nanoparticles are great interest because of new properties. When we make different size or different collaboration or composite materials, that time that materials gives different kind of properties and behaviors that may be helpful to use, that may be useful to the different applications point of view. So nanomaterials have the different kind of properties than the bulk substance. I already explained about the paper story. So which gives the mechanical strength, thermal stability, catalytic activity, electrical conductivity, magnetic and optical property. At the same time, here the nanoparticles have potential different applications which can use different application in different point of view, different materials. Here I give here the few examples for electrochemical sensing applications, catalysis application, and solar cell applications already discussed, right? Last session discussed about the solar cells and biomedical application, nanofabrication. So these are the these field are more effective for nanomaterials, which is too helpful to create new scientific ideas, new scientific products to the global environmental. So nanoparticles can providing a large surface area and enhance the activity of the uh, application, catalytic applications. So because of those reasons, we are using the nanomaterials to the different catalytic applications. Now here we are going to discuss the electrochemical sensing application. So for that, I will give you the few nanomaterials examples for metal oxide. For example, uh, in metal chemistry, we can discuss metal oxides, different variety of metals, 2D materials, metal oxides, metal nanoparticles, and more examples. So here we can discuss the metal oxide nanomaterials. Why we need to use the metal oxide nanomaterials, which gives large surface area, conductivity, biocompatibility, and chemical stability, chemical catalytic activity, magnetic properties. So for those reasons, we are using the metal oxide nanoparticles. What are the metal oxide nanoparticles? For example, we can see here in this picture uh, zirconium oxide, manganese oxide, titanium oxide, tin oxide, iron oxide, vanadium oxide, cerium oxide. So these are the few examples here for nanoscience, nano material. We can prepare metal oxide or nanomaterials. So when we use the metal oxide based element can form the number of oxide compounds with different geometries that exhibit metallic, semiconductor, and insulating characteristics. At the same time, oxide nanoparticles can exhibit unique physical and chemical property due to their limited size and high density of corner and edge of the surface sides. And then particle size here plays different important role in the oxide nanoparticles. For example, structural characteristics, electronic properties of oxide, and band gap variation, physical and chemical properties. So how to prepare these materials or nanomaterials, metal oxides and metal sulfides and 2D materials, how to prepare. So for example, we can prepare different approaches. For example, here we can prepare salt gel approach. We can use salt gel approach, hydrothermal approach, salvothermal approach, direct oxidation approach, electrodeposition, sonochemical approach. Nowadays, the sonochemical approach have high impact on the new field. It is entered the new field to prepare the green chemistry. At the same time, for example, hydrothermal method, we need to use we need to maintain the temperature, and we need to use different solvents. At the same time, microwave approach, we can use fraction of second, we can prepare the different kind of materials by using the microwave approach. And then earlier we discussed about the metal oxide nanoparticles. Now, at the same time, we can here discuss about them 2D nanomaterials, layered 2D nanomaterials. So, what are the 2D nanomaterials or layered materials? For example, we can see here graphene family, 2D chalcogenides, and 2D oxides. You can see in the graphene oxides, boron nitride, and for the chalcogenide family, MOS2, tungsten sulfide, selenide, tungsten selenide. So these are the few examples for 2D chalcogenides materials. Here we have 2D oxide materials. We can see in this picture different kind of materials we can prepare by using different approaches, as earlier we discussed. So what is the beneficial of these 2D materials in this point of view? 2D materials can use different applications. For example, organic reactions, organic applications, metal ion detection, pesticides detection, antibiotics detection, and bacterial infection detection. So when we using these materials into that field, that these materials gives uh, effective in the in the view of conductivity, surface modification, which gives the large surface area. So how to modify the surface modification? So I earlier discussed we can make the composite materials that will helpful to increase the conductivity. At the same time, when using the carbon source and the metal oxide or metal sulfide or different nanomaterials, that may be that functional groups of carbon materials can easily attract to the sulfide or metal oxide nanomaterials. So these are the advantage to use the 2D materials in the field of nanotechnology or energy related applications. So for here we can discuss about the classification of carbon materials. Yeah, we need to discuss the carbon materials. Here we have given in the examples for carbon materials: zero dimensional, one dimensional, two dimensional. For example, carbon dots, fullerene nanodiamonds, carbon nanohorn, carbon tubes, graphene, graphite nanoseeds. These carbon materials are highly effective catalytic application in different applications. For example, batteries, electrochemistry, and different applications, nanotechnology applications, nanomaterial applications. So how here we can see in the applications of carbon nanomaterials. Here, these carbon nanomaterials you can use degradation purpose, toxicity detection purpose, and different applications of electrochemistry, pollution removal, catalysis, biomedicine, nanocomposite materials, pollution removal applications, which we can utilize these carbon materials in different aspects. So for example, in electrochemistry, supercapacitor, biosensor, electrochemical sensor, and for example, catalysis, electrocatalysis, photocatalysis applications, pollution removal for heavy metal ions. I have given the few reference here for these composite materials can use the energy storage applications, and these carbon nanotubes environmental water purifications, the water purification applications and biomedical applications. We can see the biomedical applications and electrochemical sensor applications. We can utilize the carbon materials as a carbon source or carbon with metal oxide composites, metal nanomaterial composites. So now we can discuss the nano composites for sensing applications. How to use these materials? For example, 2D materials. We already discussed graphene, MS in polymer material, metal oxide, double layer hydroxides, transitional metal, sulfides, metals. I can use these materials to sensing applications. How to use the sensing applications? We can use the pure materials, pure metal oxide or metal sulfides, or we can combine with carbon materials. Here, when we combine with carbon materials with metal oxides or metal sulfide, metal 2D materials, here the synergetic effect, it will enhance the current response of the sensing performance. Those purpose, those reasons, we are using the composites materials for sensing application, electrochemical sensing application. If, mixed models, and I have given the different examples. So we come with environmental applications aspect. Nowadays, emerging pollutions in the field of pharmaceuticals contamination, industrial contaminations, agricultural pollutants. For example, in agricultural pollutions, we have more pesticides. Pesticides in industrial, more when, for example, we can take nitrophenolic compounds. We need to use the pharmaceuticals application, dyes application that are delivered from the industrial to the normal usage of water, that will affect the water contaminations. In recent study shows that in India, the pesticides based publications are too high. For example, 57% of the percentage Indians focusing on the uh, pesticides. At the same time, pharma applications 70%, surfactants, and personal care products 7%. So here we can conclude that the pharmaceuticals and pesticides affecting more in the environment and global system to the human beings. We can see that I have given the four shots of how the environmental pollutions affecting to the environment. So first, we are here we can see in the emerging pollutions of pharmaceuticals, cosmetics, and pesticides and herbicides. Other pollutions come to them through agriculture and industries and through medical aspects. These are finally comes to the surface of the water contamination, to the groundwater contaminations. Then that groundwaters again we are going to consume every day by day. So for that, we need to analyze the environmental impact. We need to analyze, urgent needs to analyze the environmental pollutions into this global system. So for how in this kind of application, how to utilize the nanotechnology to that pollution detection. Here we can see that the environmental impact of pollutions that will affect the hazardous human, animals, river products, and industrial pollution, pesticides contamination that comes to the groundwater, that will we are intake day by day as a drinking water, that will affect through food chain uh, to the human being every day. At the same time, when we are producing lot of pollution to that environmental, that will affect marine marine field. For example, when we use the more plastics, that will uh, undergoes to the sea water. When it stay long time, that time the fish or different sea uh, uh, fish can eat. That time that fish contaminate to the pollution. So nowadays also many researchers focusing on the uh, microplastics analysis through adsorption studies. So now we can going to discuss few. I have here the few example industrial and agricultural pollutions. For example, 4-nitrophenol. These 4-nitrophenols are uh, organic compound that gives toxicity and persistent to the global, and it increase harmful effect and damage the central nervous system, liver and kidney and blood and animals and human beings. And for 4-nitrophenol does not naturally occurring. So these kind of products we are creating day by day because of human beings. So we are the responsibility if this kind of pollutions in this global. So we need to uh, concern this pollution, and we need to uh, analyze, and we need to control this pollution to the environmental system. So far we are here, we are going to discuss about that pollution analysis through electrochemical sensor. At the same time, I'm going to discuss the pesticides. For example, here I'm going to discuss ethyl. Pesticides normally classified into major groups based on the chemical construction. Uh, organic, organophosphates, carbonates, organochlorides. These pesticides have some advantages and also hazardous health effect to the human being through food chain. These are the advantage for by using the pesticides in the agricultural crops. So here we are going to discuss the sensor. What is sensor? We need to know right before starting this session. We need to know what is sensor. Sensor is a device that detects events or changes in the quantities and provides a corresponding outputs. We can see that, yeah, corresponding output. The sensor are also classified in two types: physical sensor and chemical sensor. For example, physical sensor. Physical sensor is a device that provides information about the physical properties of the system. For example, pressure sensor, temperature sensor. And chemical sensor. What is chemical sensor? Chemical sensor is a device that transforms chemical informations ranging from concentration of a specific sample component to total composition analysis, and it gives the useful signal which can observe through the electrochemical approach. We can analyze the pesticides, metal ions in this chemical sensor approach. How it classified the chemical sensor? We can classify the optical sensor, electrochemical sensor, electrical sensor, mass sensitive sensor, magnetic sensor, thermometric sensor, other radiation detection sensor. Here we are going to specifically discuss about the electrochemical sensor. So what is electrochemical sensor? Which sensor which transform the electrochemical interaction analytes and electrode system into useful signal, which means when we are giving the analyte to that catalytic material that produce the signals through transducer, which means the one energy convert into the another form of energy. So we can analyze through these signals, which means our catalytic materials are absorbing the sensing ability. We are using different catalytic materials. And what is the advantage of this electrochemical approach? We can use, we can detect the low level of analytes, which mean we are now focusing the uh, pesticides and environmental pollution, right? So at the same time, which gives a high specificity and sensitivity. When we are discussing about the sensing performance, we need sensitivities that will helpful to convert the uh, energy and displace the high current density. So these are the examples. At the same time, this electrochemical approach very low cost effect while comparing to the HPLC, liquid chromatography and other techniques. This is more effective and low cost effective. So far, because of these reasons, we are focusing the electrochemical approach through these techniques. In our laboratory, we are using the auto lab. This is one is new version of electrochemical setup. These electrochemical applications, we can use different chemical and biomedical applications, industrial and clinical, and food monitoring application and environmental monitoring applications. This is the electrochemical setup for analyzing the catalysis, how it perform for pollutant or any other analytes. Here we are using three different electrode system to analyze the pollutions or analyte, different kind of analytes. A working electrode and reference electrode and counter electrode. Here the working electrode using a glassy carbon electrode and a strip electrode. Nowadays the strip electrode also using as a working electrode that we can able to use once in a time. So in research field, we are using the glassy carbon electrode. We can polish and we can use several times. We remove the catalyst from that carbon surface. Then we can use them glassy carbon electrode. So at the same time here, the platinum electrode using as a counter electrode. This is the three electrode system, how it workings. We can see in this figure. So first we are going to discuss the diphenylamine cations detection through electrochemical sensing application by using micro magnesium nickel sulfide based microspheres at a carbon source. In this schematic, for understanding, we can see in this image how the industrial waste or antioxidant waste analyzed through the electrochemical system. First, for example, here we are going to discuss about the diphenylamine cation. Where we are using the diphenylamine we are using as an antioxidant to protect and preserve the food products in, for example, grapes, apple, strawberry. That applications most of the industrials using them DP as a antioxidant to preserve the foods. That time when the limit of 0.1 mg per gram of antioxidant of diphenylamine increase the dosage level into our body, that time affect our global system. So for we need to analyze the diphenylamine cation through the electrochemical system or any other system. But here we are focusing the electrochemical system due to the reasons of cost effective and highly effective sensing ability. Uh, here we are focusing manganese based nickel sulfide at carbon source, and we tapcast the catalyst material to the glassy carbon surface. Then that electrode using as a working electrode into the electrochemical system. Then the peaks analytes use the respective signals of diphenylamine sensor. This this paper is published in Crystal Engineering Communication (RSC) publication in 2018. So, how to prepare this material? This is the protocol for the preparation of manganese-based nickel sulfide, and then how to apply the carbon source. After preparing this compound, we use the polydopamine as a carbon source. Then it allowed to argon atmosphere at the temperature of 450 degrees Celsius 3 hours. Then it converts the polydopamine convert into the carbon source. This catalyst then utilized for the electrochemical sensing applications of diphenylamine. This is a schematic illustration of this material preparation, and side by I have given the possible reaction mechanism of this material preparation. You can see here the as prepared materials showing the crystal structure features in the plane of 010 plane and 001 plane, and at the same time we in the figure B shown the XRD patterns which were accurately merging into the PDF patterns of known. Here we can observe the unknown peaks that due to the impurities. Then we can, when we are preparing the nanomaterials or micro structured materials, normally we need to analyze and confirm the XRD, X-ray diffraction, which means when we analyze the XRD, then only we will know that our prepared materials get the compound formations. That's why we are using XRD analysis before starting the applications point of view. Here then we need, here later we analyze the X-ray diffraction study. Now we need to see how the structural features obtained in the as prepared materials. We can see these left side shown the same images of as prepared materials, and we conclude with the mapping analysis, which means here when we using the mapping analysis, our prepared materials of elements presence, we using magnesium, nickel sulfide and carbon source. So we need to confirm the elemental conformations through the elemental mapping analysis. So far we are using the elemental mapping analysis and confirm the uh, presence of metals. At the same time, here we discuss the scanning electron microscopy. In advanced, we are focusing the high resolution time image for to observe the lattice parameters, which means the dislocation or location of despacing we can observe through this high resolution image, and the nanostructural feature we can observe. We can see that these microsphere have combined with different nano seeds that observing the despacing near 2.01 nanometer. And after the analysis of structural features, we need to confirm the chemical composition in the binding energy level. So here we are confirming the binding energy levels of magnesium and nickel and carbon and sulfur. So here we observe the oxidation state and binding energy of the aspect material. After the analyzing and confirming the materials, we can conclude that our compound have pure materials, and we can analyze that materials we can utilize the application point of view. Here we are using that materials for diphenylamine sensing. When here the potential window showing that 0 minus 0.4 to 0.8. Here the mechanisms of the electrochemical sensing. So here in this case you can see that when we are introducing the sunlight into the glassy carbon electrode modified catalyst, that time the sensing performance here appeared through the signals. This is first when we are adding the diphenylamine to that electro catalyst in by using phosphate buffer solution medium. That time diphenylamine can lose the electron and form the diphenylamine cation. Then that diphenylamine diphenylamine again converting into diphenylamine conversions in the fixed potential. At the same time, we observed the different pH medium, phosphate buffer saline medium. Here we can observe the pH 9 is the better performance for diphenylamine sensing. At the same time, we need to analyze the concentration, fixed current, and we increase the concentration. That time the current response showing the linear response due to the which means our catalyst materials giving the response in the fixed potential, fixed current response in the fixed potential medium up to 120 micromolar. At the same time, after analyzing confirming this one, next we fixed the uh, concentration of the sunlight and analyzed the current response in the different voltage millivolt. Here we analyzing 22 100 millivolt. So we can observe the linear responses, which means our diphenylamine, our catalyst, our prepared catalyst gives good chemical sensing displays. At the same time, when the concentration of the diphenylamine increasing, that time the peak responses moves towards the positive sides. That means the diphenylamine in that concentration, higher concentration, it forming the polymer. So because of this reason, the peak response moved towards the positive side. Then we need to analyze how these sensor performing uh, loss detection limit. So for this to identify these characteristics, we are analyzing the differential pulse voltammetry. We are using the differential pulse voltammetry for the analysis of chemical sensing. At the same time, we are different application. We are using the amperometric titrations. Comparing to the amperometric sensor, the voltammetric applications of DPV performance giving them highly sensitive performance. Because of these reasons, we are replacing the differential pulse voltammetry for these applications. At the same time, we analyzed the interfering compounds of this diphenylamine, which not showing the not interfering with that potential window of our catalyst, showing only the diphenylamine. So we can observe from this catalytic response our prepared materials we can uh, which use the sustainable sensing performance towards the applications of pollution monitoring a diphenylamine cation. For next, we are focusing the nitrophenol by using the graphene oxide and TiO2 composite materials. I already discussed the composite formations which may helpful to the synergetic effect that may displace the current density will be high. So because of these reasons, we are using the composite materials for the electrochemical applications. So in this study, we are going to analyze or we are going to discuss the 4-nitrophenol by using electrochemical approach, which this published by New Journal of Chemistry in the RSC publication in 2020. So how to prepare these composite materials? We can prepare simply these TiO2 nanomaterials we prepared through salt gel approach. Then that's all prepared TiO2 nanoparticles combined with graphene oxides because of the synergetic effect reasons by using ultrasonication method. Then it convert this prepared catalyst materials using this GC surface as a surface modification. When we normally we can use the glassy carbon electrode as a sensing material, sensing electrode, but due to the agglomeration and different disadvantages, we need to modify the electrode surfaces by using different new catalytic materials. Here we are utilizing the graphene oxide with the TiO2 nanomaterials for the applications of 4-nitrophenol sensing. This is the schematic illustration for the hazardous 4-nitrophenol sensing through electrochemical approach. Uh, at the same time, now we are going to discuss here the prepared material, how to confirm the characteristics. Here we can see the crystal structure of TiO2 materials. Here we observe the two different phase. One is anatase and rotile phase. The primary phase we have observed anatase and secondary phase is rotile phase. And these XRD patterns clearly observed and confirmed with the previous literature of JCPTS value. Then we analyzed the functional groups by using FTIR spectroscopy and Raman spectroscopy. Here the FTIR showing the TiO2 450 vibration formation in the region of 550, which confirms the formation of TiO2 nanomaterials. And at the same time, here we can observe the Raman shift for this TiO2 materials with the combination of composite materials. Here we can observe the different DG bands for to observe the to hybridization of graphene oxides and graphene defects in these characteristics. Then we move to the high resolution TEM image to observe the structural features of graphene oxides and TiO2 and composite materials. That when the pristine TiO2 materials showing the crystalline lattice despacing 0.3381 nanometers. When we introduce the composite materials, the time the despacing of 0.24 nanometer, which means that is the despacing will be decreasing by when we introduce in the composite materials. And we observed the elemental mapping analysis to confirm the presence of metals. And we the EDX spectrum showing the confirming the presence of metal ions. At the same time, we analyzed the XPS study to confirm the energy level of composite materials and pristine nanomaterials. And we observed the surface of by surface study by observing using bed isotherms for different pristine and graphene oxide and composite materials. And we move forward and to the electrochemical applications. By before here we can observe that the ferricyanide system we are observed for different modified electrodes. Here we can confirm, we can analyze that the electron transferability of the electrode by using the ferricyanide system Fe3 to Fe4 minus, Fe4 minus to Fe3 minus, the redox behavior we can observe, and how much the which electrode system gives the high electron transfer rate can observe through this analysis. And at the same time we can observe the ES spectrum for resistivity of the electrode material. When we discussing about the resistivity of the electrode material, that time the resistivity is directly proportional to the sensing performance of. When we reduce the resistivity of the electrode system, that will be helpful and enhance the catalytic performance for the electrochemical sensing performance. Here we can have seen that for nitrophenol convert direct conversion by using 4 electron and 4 proton transformations. Here the reduction potential we can observe the direct electron transfer. At the same time, which in reverse process we can observe 2 electron and 2 proton process for hydroxy amino group to nitrosol group. We can observe here, we can observe the 2 electron system and 4 electron system. After analyzing these characteristics, we move forward the buffer confirmation, which buffer saline is suitable or effective to detect the 4-nitrophenol. Here we can observe that 3, 5 and 7 pH of buffer saline we observed, but almost we observed this same current, but comparing to the other buffer saline, the pH 7 effective for electrochemical sensing of 4-nitrophenol. So Further, we analyzed by using this buffer for the other characteristics. We already I discussed them: fixed current response and increasing the concentration, which means we are observing the molar performance of how much this catalyst material can detect the 4-nitrophenol. Here we observe the 0 to 300 micromolar. When it reached the 300, the time the peak can clearly see that the peak was shifted towards the negative side, which means after reaching this amount of my 300 micromolar of 4-nitrophenol, we cannot able to no space, no surface to interfere with the catalyst. So for because of this reason, the uh, peak shifted towards the negative sides, and we are analyzing the uh, current responses by using different voltages. Then we move forward the differential pulse voltammetry analysis to observe how much we can able to detect the 4-nitrophenol by using our modified catalyst. You can see that the 0.02 micromolar to 80.57 micromolar of 4-nitrophenol gives the linear response of electrochemical sensing performance, which means that much amount of uh, nitrophenol can able to observe by linearly. So after reaching that 80.57 micromolar of 4-nitrophenol, that peak was shifted, which means no space available or observed to the electrode system. At the same time, we observed them uh, interfering substances to the electrochemical performance by using DPV approach. Here we observed the different metal ions, different nitro compounds, and different biological compounds to observe the interfering compounds. Here we can observe that metal ions and biological compounds almost not interfere that much. But when we using the nitro compound, actually this 4-nitrophenol is nitro compound. At the same time, when we using or interfering with other nitro compounds, for example 2-nitrophenol nitrobenzene, that time it is affecting the electrocatalyst in the buffer saline. But you can observe that these nitro compounds observing the different potential window. Our system observing the minus 0.6 voltage, but the interfering compounds observing different potentials. So this system cannot able to interfere our catalyst material. So because of these reasons, we study the interfering compounds and we analyzing the different electrode system by using this catalyst to observe them how this catalyst, our prepared catalyst, only giving the good results for our electrode materials or different electrode materials. So we need to analyze that one. Then only we can move this application move forward to the different areas, and we analyze the performance of detect with the different time intervals also. So next study we are going to discuss the lanthanides 3 plus doped and 3 plus doped uh, titanium nanoparticles, decorated functionalized multi-wall carbon nanotubes as a catalyst material for novel electrochemical sensing of paraxanethyl. I already discussed about the paraxan ethyl is a kind of pesticides that can helpful to agriculture field. At the same time, it affect the eco global by way of food chain. So that time when it reaches the particular amount of intake level, we also need to detect and control the pesticides in the global. So for we analyzing the sensing performance of sensing, we need to analyze and for by using different electrocatalyst materials and observe the sensing performance. And when we observe like this, we can able to detect or detect and observe and control the universe by using this system. So because of this reason, we are going to use the electrochemical approach, which means we can easily uh, observe the sensing performance by using autolab or different electrochemical characteristics. This paper published in Nanoscale Advances in 2020, so in RSC publications. Here you can see that the preparation of lanthanum La3 plus doped TiO2 nanoparticles by using a polycondensation method, and which we so this is the structural features and uh, how it converting to the doping formation and oxygen vacancy. And this is the structural crystal structure features and X-ray studies and FTIR analysis for this material preparation, and how the characteristics observed by uh, uh, TEM analysis. We can see in here the La3 plus doped. When the TiO2 nanoparticles observe the particle size 0.2 micrometer, when we introduce the La3 plus into the TiO2 nanoparticles, that that particles restrict the growth of TiO2 nanoparticles, which means it creates the boundary to that uh, system due to the ionic radius. So we can observe here the after introducing the La3 plus into the TiO2 nanoparticles, the size also decreased. We can here we can observe the composite materials formation by using carbon materials with La3 plus doped nanoparticles, and we observed the PET analysis for that characteristics, and we observed the XPS study for the presence of energy level confirmation of energy level. And when we normally Ta4 plus when we introducing the La3 plus into this system, the La3 plus provoking to that Ta4 plus state to Ta3 plus state, and it forms enter to the La3 plus to into this system. Because due to these reasons, the La3 plus doped well onto that composite materials, TiO2 nanomaterials. And here we observed them paraxan ethyl by using the ferricene system, and we analyzing the different ratio for electron transfer rate, and we are observing them the paraxan ethyl to the different catalyst modified electrode system. Here we observed the final composite materials, and we observed the pH different phosphate buffer saline for the analysis of electrode system. And this is the schematic illustration for the electrochemical sensing performance of paraxan ethyl into the direct electron transfer and reversible electron transfer process, and we analyzing the catalytic, we analyzing the characteristics by using different approaches, and we finally analyze DPV, differential pulse odometry, and we analyzing the interfering compounds by using DPV approach, and we showing the paroxene ethyl at the modified electrode surfaces have not observed the interfering compounds, which means our catalyst materials highly effective for the detection of paroxene ethyl. For summary, we can conclude that the electrochemical sensor of pollutant and pesticide we observed, for example, TiO2 nanoparticles based composite materials, showing the low detection limit and wide linear range and high sensitivity. At the same time, diphenylamine showing the low detection limit of 16 nanometer and linear range up to 76 micromolar, and our reports represents the La3 plus doped nanoparticle showing the low detection limit of paroxene ethyl for 0.0019 micromolar, and linear we observed two different linear, and sensitivity we observed highly sensitive around 7.6 microampere. Overall, our approach, our sustainable or our prepared material, we can introduce the environmental applications to analyze the sensing performance in the characteristics of different by using different characteristics, which showing the load overall conclusion, our prepared materials, and in the electrochemical approach showing low detection limit, wide linear range, good sensitivity and selectivity for the electrode system. So what is the future challenge of our nanotechnology? So we need to help to clean up past environmental damage, correct present environmental problems, and prevent future environmental impacts. So these are challenges we need to analyze by using the nanotechnology, which may be helpful to sustain the planet for future generations. Finally, I thank to organizing committee members of Sri Vidya Mandir Arts and Science College, Uttangarai. Especially thanks to the organizing committee members, Professor Govindraj and Professor Dayanandan, for giving the wonderful opportunity to deliver the speech here. Thank you so much for them. And finally, I thank to everyone. If you have any queries, please we can discuss here. Thank you so much.
Thank you, Professor.
Okay, sir.
Thank you for your adorable presentation, sir. Once again, thank you, sir.
Thank you. Thank you. Thank you so much.
Okay, thank you, Professor.
Thank you, sir. Thank you, sir. If you have any
I
queries,
invite Ms. G. Vimala, Assistant Professor, Department of Chemistry, Sri Vidya Mandir Arts and Science College, to welcome and introduce our chief guest.
I am profusely overjoyed to take the opportunity to introduce our chief guest of the day. He is none other than Professor Dr. K. Shivakumar, Gitam University, Hyderabad. He completed his graduate at Kakatiya University in the year 1998. He completed his MSc in Organic Chemistry at Osmania University in the year 2000. He completed PhD Chemistry at Kakatiya University, Warangal. He was working as an assistant professor for 10 years in SRPG College, Halamgonda, Warangal in the year 2000 to 2010. Presently, he is working as an associate professor in Department of Chemistry, Gitam University, Hyderabad. From the year 2010 onwards, he has 19 years experience in teaching and research in the field of chemistry. He has published more than 8 international journals and 14 national journals. He presented 25 papers at international and national conferences. He had been guided 5 students in Gitam University, Hyderabad. He received project fund sponsored by UGC MRP in the year 2013. He is working in the field of synthetic organic chemistry, medicinal chemistry, microwave assisted organic synthesis, and solid state solvent free radical, etc. He has organized various national symposiums on the title of Materials in Health Care, sponsored by Society for Material Chemistry and BRN from 6 to 8 September 2018. He has organized national level workshop on the title of Big Data Applications in Drug Reproposing BDA DR 17 in the year 2017. He has organized national level conference on the title of Emerging Trend in Nuclear and Chemical Technology NACT 2012, sponsored by INS Mumbai and BRNS DAE in the year 2012. He is a life member in ISCA, Indian Science Congress Association, and INCAS, Indian Association of Nuclear Chemists and Allied Scientists, and ISCIS, International Society for Environmental Information Sciences. Concluding, I wish Professor Dr. K. Shivakumar make successful and enlightening this conference. Thank you.
Am I audible? No? Am I audible?
Yes, sir. Audible, sir.
Thank you very much for the kind introduction. Just share my screen. My topic is the development of new methods in organics. Whereas generally the conventional synthesis are different. Whatever we are, the conventional synthesis and new methodologies which we are applying in organic synthesis. So, what are my contents in this talk? One is solid state organic synthesis, combinatorial synthesis, applying for the polymer chemistry also. Some of the new reagents which we are doing. First, let us discuss about the microwave assisted synthesis. This microwave assisted organic synthesis, which is now it is emerged already. There is a lot of research is lead organic compounds, particularly activity containing compounds. The technique which is offers very simple, fast. Due to this timeless and easy workability, this microwave assisted environmentally benign. So this is the alternative to environmentally unacceptable procedures, where which is giving the pollution. We are not using any expensive and toxic reagents. Just simply small reagents and the big reactions we need. Microwave organic assisted synthesis. In the laboratory, we started with this conventional microwave, and later on we shifted into the laboratory microwave. Nowadays, the microwave reactors having a single coil, multiple do multiple reactions, whereas a conventional one we will do only one reaction with an interval timings. Conventional operatives, Samsung, LG, and what is the difference between the conventional? Mainly the conventional heating. When we heating a flask, first the energy is taken by the flask. The flask is given to the reactants. The reactants, whatever the lower side, this lower side containing the reactants takes the energy, and this energy, after taking the sufficient energy, they are excited. So the energy which is given to the neighboring atoms. So that means the energy is randomly the conventional energy is transferred. All the molecules will not excited in a time. They are excited only sometime. So all the molecules, if they are excited at a time, they will give the product at a time. But in the conventional, what happens? The randomly energy transfer takes place. The randomly the molecules gets excited. When molecules are gets excited, only the yields of the products than 50 not even get. But when we use a microwave reactor, the microwaves where we are using the vessels or RT flash, these are transparent to the microwaves. Directly the microwaves is going inside the sample, and the molecules are gets excited at a time, and the products also forms. That means we get 100%, nearly 90 to 100% of the yields by the. So these are the main advantages. Already told you, faster reactions, temperature, which is when conventional heating, microwave heating, it is about 1,000 times more. Immediately we will get the products, and that products need not to separate, need not to purify. The pure compounds will get better yields, higher purity, and we will save the energy. Save the energy, and also there is a uniform heating. The uniform heating is given by the compounds, where the solvents also which we use, solvents which take the use the reactants. High in the microwave assisted. Now coming to which type of reactions we can perform in the microwave. We can do acetylation, amination, coupling, cyclization, there are so many named reactions also performed in the Erlenmeyer lactone synthesis. Solvent-free. Now coming to, there are some reactions which we performed. First one, which is a simple step, very easy step. We have prepared an avangal condensation. Added as a base. Then the aldehyde, the alkyl methylene cyanates. So these are the compounds which we have alkyl, the aryl aldehydes. These are the aryl aldehydes which we are used, whereas the alkyl group we got different types of products and it was published. So this is one type of publication. And also there is another methodology which is trial in the presence of lithium chloride, aluminum, solid support, and the microwave gets a product of 5-oxo, 5-tetrahydro 4H. That this lithium chloride and the alumina as a substance. And this is nothing but like a Bignelli reaction. We also taken so many arylic compounds. So these are the arylic compounds we have taken. We got 90 pure compounds we have not purified completely the pure. Now coming to another reaction, we performed the multi-steps also. In the multi-steps, this is the reaction which is we have taken more active compound, substituted 1,8-naphthalene, when we have condensed with these different types of coumarins. That both these two are condensed and gets the phosphorus oxychloride, formamide, silica as organic synthesis, Wills-Mayer-Hack reaction takes place. Pyrazole carbaldehyde is formed. Pyrazole carbaldehyde formed and it is confirmed by all the published. Now coming to another one, we have also performed the multi-steps. Particularly, we have synthesized 9-aryl 6,4-triazolo 1,8. Thus, this is the schematic way. We have taken this 2-amino nicotinaldehyde and the various benzyl cyanates. Its condensation takes place. Got a 2-amino 3-trifluoromethylphenyl. When it is performed with use the 2-oxo compound, and this 2-oxo compound from these onwards we have performed this reaction phosphorus oxychloride. So this phosphorus oxychloride, which is 2-chloro compound, then this 2-chloro compound, when it is treated with hydrazine hydrate in presence of ethanol, so got This is the aryl aldehyde when mixed with the aryl aldehyde treated with the copper diacetate. Even we have treated with the iodobenzene diacetate also, copper diacetate. Triazole compound obtained, and it is has a antimicrobial virus activity also, and it is also published. Now coming to the another organic synthesis made with the solids or solid phase organic synthesis. Most of the organic reactions have been studied in solution only. So the reactants takes in the form of solution, then the product will be, because of one reason, the reason philosophy, no corpora resi. This, what is mean by this no reaction? Even our rice is cooked with the water. Our rice is cooked with the water. Whatever the hard material is cooked, become a soft. So this is also one kind of reaction. So without the fluid, without liquid, without solvent, reactions will does not take place. But solid state is also one of the efficient, the more selective than the solution reactions. In many cases, the solid state reaction proceeds much faster than the solution reaction. Proved by our reactions and even our experience also. These organic reactions are generally usually carried out reactants and products, reactants and reagents at room temperatures, finely poured. In some cases, will add some catalytic amount of solutions, solvents, catalytic amounts only, or to accelerate the reaction, we will use some heating, radiating with the ultrasound, or by grinding mortar and pistons. Mortar and piston is also, which is very useful to conduct the organic reactions. We will use most of the times. Why? Because the lecture you heard about nanomaterials. Particle size will goes low. When the particle size is goes low, their potential energy. So when we use a grinding, so by the grinding, what happens? The particle size will be goes down. Their potentiality will, the particle size when it is down, the potentiality will goes. So automatically it will goes. One of the reaction which we have performed in the laboratory, so convenient synthesis, acid hydroxide, mercuric acid. We also performed with the copper acetate, other compounds also. Have taken the hydrazine carbazide compound, and this compound is got a product of the, and these are the compounds with high yields. This is the mechanism which forms a mercuric acetate. After that, there is a double bond formed between the nitrogen and again one mercury come into the picture, react with one more molecule. So this is the mechanism which we have shown, and it is also proved. And we have blended the microwave assisted solid state. This is the blending reaction. So we have taken the two oxo alpha chloroethyl acetate. When it is treated with alpha chloroethyl acetate, the N alkyl substituted with the microwave assisted dimethyl formamide as a solid state. So only the catalytic amount of DMF is added to accelerate the microwave assisted organic reactions, and it is solid state only we harm but this product, and this is treated with hydrogen hydrate. This is only the conventional way. Why? Because we tried a lot, but there are some fumes which is generating with the hydrate. Even though we have used the hydrogen hydrochloride also, but hydrogen hydrochloride is not reacting with the hydrazide formation taking place. So that is only the reaction which is conventionally have done in the presence of. Then again, this is added. The aldehyde is added to this hydrazide. So of BTS, paratoluene acid, by grinding iodobenzene diacetate. We have used it with copper diacetate also. 1,3,4 oxidizole formation. The oxidizoles also, which are very active bonds, they are having antimicrobial reactions which we have performed solid state. Now coming to another synthesis, organic synthesis, which is come to combinatorial, or we can also call it as a combinatorial. Calling it is as a combinatorial. Multidisciplinary. Combinatorial chemistry is a smart technique for development of new libraries in pharmacology. Particularly in pharmacology, the lead compounds we can find perform the series of the organic compounds in a single reaction, which we can call it as a libraries, which can of organic compounds which are formed in a single reaction. Pharmacology, particularly they will use. For example, this combinatorial chemistry, if I can have performed in the laboratory, it is also first. Why? Because we are blending this microwave organic solid phase reactions. So my idea is that we can blend this combinatorial chemistry. Have any interest, you can type of combinatorial chemistry. For example, to introduce this, if I can take benzene, so benzene and derivatives, whatever the derivatives, I am performing a nitration. So what is a nitration? The nitration we need to do O2, NO3, and do a product. They do a product of nitro compound. Similarly, what is the condition of this reaction generally? So first we will prepare the nitration mixture, then we will add the benzene to the nitration mixture, and it gives the nitrobenzene. What is the condition? Just we will heat. By that heat, automatically nitrous oxide formation takes place. The fumes will be seized. After seizing the fumes, if we poured into the ice cold water, we will get yellow colored liquid, which is. Similarly, if we can take the nitrobenzene, again, if we can perform the nitration, what we will get? We will get meta-nitrobenzene. This is can done by in the laboratory. Nitrobenzene you can take in the meta-dinitrobenzene. This meta-dinitrobenzene, it is a solid. It is a solid. Okay, so this is liquid and it is a solid. And similarly, you can take the chlorobenzene and perform the nitration. What we will get? The ortho-nitro substituted and para-nitro substituted nitrobenzene, which is. So what is the condition? What main condition is that first the nitration mixture which generates the nitronium ion NO2 plus, then it can be reacted with a different types of benzene or nitrobenzene or chlorobenzene, bromobenzene. But if I can take a flask, in that flask, I will take chlorobenzene, benzene, nitrobenzene, 3 compounds. And I will add the nitration mixture to the compound. So what happens? We will get 3 products in a single reaction. 3 products in a single reaction. This is the reaction which is in a single shot, too many birds die like that. So the combinatorial synthesis, one reaction will perform the number of variable compounds, organic compounds obtained, that we can call it. So you can see the synthesizing a large number of similar compounds in a short period of time, which is called as a combinatorial. That compounds which are generated are analogs of the compounds are already biological active compounds which get that compounds. The chemist want to know the new medicine. For that, it is a more effective one and causes very less side effects. So, the definition of combinatorial chemistry, which is a technique by which the large number of different but structurally similar compounds are produced rapidly and they are submitted pharmacological tests. Even the activity also nowadays, single variable activity and multiple variable activity, the multiple variable activity by the combinatorial synthesis. This technique, which is used in same reaction conditions, large range of involves both the synthesis and screening of the large sets of compounds, which are called it as. What are the strategies of this conventional strategies of this combinatorial chemistry? Combinatorial chemistry is a many molecules at a time which is formed, whereas a conventional one molecule at a time only. And it is should be make purity test. But these many molecule at a time we can make test purity. Hundreds of the molecules in a month we can prepare, but thousands of the molecules. Lower lead generation, and it is a fast lead generation. And it is a high risk of failure, but it is a low risk of failure. That lead identification even in the conventional. One example I will explain because the time is not permittable. One example I will explain, that is mixed and split combinatorial synthesis. This mixed and split combinatorial synthesis can be done in a particularly protein synthesis. What are the advantage of this one, which is faster, billions of the compound conditions. There is economical reaction, very easy to isolate identification of active compounds. Drug discovery is also very easy. The optimization of the drug is also very slightly differences found. And now this combinatorial synthesis, particularly it is applied in solid phase. So the solid phase synthesis, particularly it should contain a solid. With that solid support, we can synthesize the polymers. So that solid, it should be a resin, which we can call it as a resin beads. And this first it is applied the solid phase synthesis, particularly the Marifil resin synthesis. There, the bead, whatever the polymer, it is a bead which is a cross-linked polymer which is having so many active sites, which is the starting material, which is the bond with the starting material. So these beads added the reagents, and these reagents, excess reagents is also which cannot react and it can be removed. Products also easily can be. These are the advantages of this solid. Particularly the resin, it contains a resin, and this bead, it contains a linker. Linker, it has a active functional group. This functional group is initiated, and there are some linkers which are having the names. This is the Bang linker, which has a carboxylic acid as a compound, which is an active. And the Marifin resin is formation of particularly suitable to the peptide bonds. This is the compound which is a ring resin having a carboxamide. These are the linkers and as well as the functional groups, which functional group. Now, Marifil resin synthesis. What is conventional Marifil? Generally, the conventional Marifil. This is the solid resin bead, and this resin bead, it contains a linker. Linker, it contains an active functional group. And this active functional group, first it is added by the protected, N-protected, the VOC, N-protected amino acid. So N-protected amino acid is added to this linker functional group first. Then this N-protected one, which is the protection. After that, this NH2, again it is coupling with the another amino acid. So this acid group, which is N-protected one, other amino acid, it is added to this. So one peptide bond formation takes place. After the peptide bond formation, again deprotection, again adding one more compound, again deprotection, linking. So coupling, deprotection, coupling, deprotection, coupling, deprotection. Finally, we will get the A1, A2, amino acid 1, amino acid 2, like that amino acid N number, finally NH2. When it is treated with the HF, it releases the solid support and we get a polymer. The polypeptide chain is formed. This is the reaction which is conventional. When we apply to the combinatorial synthesis, one method which is called it as a mixed and split method. What is the mixed and split method? You can see here. I have taken lysine, alanine, phenylalanine, valine, or whatever it is. So we have taken the resin plus glycine, resin plus alanine, resin plus amino acid. First, the resins are added to 1,1 glycine, amino acid, whatever it is. So all these are taken in a single vessel. All these are taken in a single vessel. So we prepared a single vessel. Then this vessel containing all the compounds are splitted into different vessels. So each vessel, it contains, I have taken 1, 2, 3, 4, 5 amino acid containing resins. and all are distributed. These are the distributed 5 flasks, and the 5 flasks is added after deprotection. It is added, this flask is added glycine, this flask is added alanine, this flask is added phenylalanine, this flask is added violin, and this flask is added saline. So what happens, this alanine is added the glycine, 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 glycine. Total how many products are formed in this? This 5 peptide bonds are formed, 5 peptide bonds. And here is also alanine, alanine, phenylalanine, alanine, like that 5 variables of peptide bonds. 5 variables of peptide bonds, 5 variables, 5 variables. So one peptide bond, 5 variables is obtained. All these are mixed in again a vessel, deprotected. Then again it is separated. When it is separated, each and every flask, it contains 25 types of monopeptide compounds are present. After that 25, when we add again 5, 25 into 5, 125 compounds, 125 dipeptide compounds are. Again, if we can mix that compounds and separate it in 5 vessels, again you can add 5 amino acids, the tripeptides, you can imagine 125 into 5. Like that very simple way, I have this method in the mixed and split method. I have taken 3 vessels. These 3 vessels are, first I have taken this. Then I am adding very simple amino acid, alanine, valine, phenylalanine. So all this, it contains alanine added, valine added, phenylalanine added. So whatever the amino acid is added first. So this is a pure alanine containing, valine containing, phenylalanine containing compounds. Then these 3 taken into a single vessel and deprotection takes place. After deprotection, it will be splitted into 3 vessels. So each vessel, it contains red color, blue color, yellow. Red color, blue color, yellow. Red color, blue color, yellow. Then again, these 3 vessels is added alanine, valine, and phenyl. So again, what happens when it is added to this? So here you can see alanine, alanine, phenylalanine, alanine. This is red color, blue color, yellow color is added by blue. And here it is all yellow colors. Last one, second one. Here it is all the red colors. Again, these 3 are mixed. Deprotection, again splitted. So when it is splitted, the mixed amino acid peptide bonds are. And this is again is added. So there are 3 times we are adding. In that 3 times, which that means 3 into 3, total 27. Vessel, it contains 9 peptides. Number of tripeptides obtained 9 plus 9 plus 9. 27 compounds. 3 vessels containing compound. In the beginning, I have taken 5. So 5 into 5, initially 25. That 25 into 5, which become 125. When we 3 times the reaction. 27 tripeptides in a 3 vials, which is all these 27 compounds, the test mixtures removed by the beads. After that, they will sent into the high throughput screening. Because of that high throughput screening, automatically the screening will be done, and that screening will give the compounds. If I can take the 20 amino acids into 20 amino vessels and mix it with the 5 times the hexapeptides, what happens, 34 million products will be 34 million products. Only with 1, 2, 3, 4, 5, 6 hexapeptide. That means only 6 times. By the 6 times only 34 million products will be okay. They are the hexadipeptides in a single vial. This is the common problem. Whatever the polymers, the conditions, if it is the same for forming the polymer, you can do in a combinatorial process. For the mixing combinatorial synthesis has a 96 vials, has a 105 vials also. Coming to, there are some new reagents. So one of we performed one agent, that is electrophilic cyanide, not azidic. Generally, when we perform a cyanide, the cyanide, it contains a minus charge. The cyanide, which is very toxic in nature, very toxic in nature. So while using the cyanide, the toxic nature, environmentally hazardous and toxic nature it contains, due to this cyanide, instead of the cyanide, the negative charge, make the cyanide into the electrophilic nature, converting in nucleophilic. Then cyanide doesn't have any toxic nature. So develop one reagent, the new reagent, this reagent which is called N-phenyl paratoluene sulfonamide. Paratoluene sulfonamide, which contains this cyanide is electrophilic cyanating agent. So electrophilic cyanating agent, generally, if for example, if I can take like this C double bond O. So if this type of compounds, if any compounds are there, like diethyl acetate, where this active methylene carbon containing compounds, immediately when we treated with the base and this electrophilic cyanating agent NCT reacted, automatically use a cyanide here. Bond O double bond. Why? Because it generates with the base, it generates a carbon ion, and our cyanide, it is combined, which is a bond which is always takes place towards nitrogen side, and the cyanide, it gets a positive charge here, carbon, and that carbon is have performed too many reactions. Reaction which is fossil synthesis of 2-amino benzoxazoles, which are the benzoxazole, 2-amino benzoxazoles and imidazoles also. Very active compounds, and perform the electrophilic cyanating agent 5 degrees centigrade to room temperature. But tetrahydrofuran should be dry. So if it is contains any moisture, automatically the reaction got this compound. Comes as a N plus. After that, the cyanide proposed. And another one which is also compound, which is a T3P. On N compounds, it is also placed in a tetrahedral structure of the T3P is this. This compound is also very useful in preparation of amides. The reagent, and these are the different compounds which we have taken, and it was published. this is the interesting one where my colleague is used the lemon juice, performed reaction under ultraviolet, have prepared uric acid, oxidation formation takes place. Isolactone formation takes place. There is electron in the presence of published in combinatorial chemistry. Lemon juice also, it has a secret accelerated the reaction under the ultrasound and as a result to 400 different temperatures. This the mechanism which they proposed, and so with this I conclude my session. Thank you very much. Thank you, Professor Govindraj, for giving this opportunity. So any doubt you have,
Thank you, Professor.
if I can explain clearly, it will take some more time. So
Okay, Professor. No problem, Professor. Okay, wonderful session, Professor. Okay. 1 second, Professor.
okay.
I thanked our chief guest and he clearly explained about the development of new methods in organic synthesis, microwave assisted organic synthesis. He described about MAOS and its application, efficient synthesis using iodobenzene, diacetate in the solid state, combinatorial synthesis, etc. Thank you for your adorable presence, sir. Thank you once again.
Thank you very much.
Or unlimited, sir. Because the next one, method in validity is sir.
படிச்சு ரெக்கார்ட் பண்ணவா சரி சரி ரெக்கார்ட் பண்ணு
இல்ல நீங்க பண்ணிக்கோங்க
சென்னை பேசுறேன்
பேசிக்கோங்க சார். Now, I invite Mr. C. Tirumurugan, Assistant Professor of Chemistry, Sri Vidyamandir Arts and Science College, Uttangarai, to give vote of thanks.
Good evening to all. I feel honored, privileged to get the opportunity to propose a vote of thanks in this special day. Good evening to all. I feel honored, privileged to get the opportunity to propose a vote of thanks on this special day. First, on behalf of the principal, vice principal, on behalf of the HOD, faculty, and students of the Department of Chemistry, I would like to express my heartfelt gratitude to the college administration and secretary, additional secretary for giving permission to hold this event. Thank you, sir. I would like to express my sincere thanks to the principal and vice principal of this college for giving permission and encouragement to hold this conference. Thank you, sir. On behalf of the management, HOD, faculty, and students in Department of Chemistry, I convey records and hearty thanks to our chief guest, Professor V. Raj from Periyar University, Professor S. Govinathan from Muthurangam Government Arts College, Professor Suzuhan, Professor M.S. Surendra Babu, Professor S. Sudarshan, Professor K. Savakumar, Professor Mani Govindaswamy, Professor G. Satyam, our college alumni, Professor Raja Meru, Professor Z. Kavida, and Professor Dr. R. Dayananda in our department. The special guest who attended the seminar and helped to make the event success by inculcating in the young and energetic mind of our student the idea of future researches and various research record for the world. I also like to thank all honorable delegates who blessed us with their presence. Deepest appreciation to the technical committee for making this arrangement. On behalf of the administration and the faculty of chemistry, we most sincere appreciation to the students who shared passionately for these 2 days and received the necessary feedback and are now happily waiting to leave. Thank you to all. Thank you again for making this event successful. Thank you.
Next, national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Adi sir,